Welcome, friends. Before we begin, take a slow breath and let the air settle gently. Wherever you are, I hope you're warm, comfortable, and ready to drift into the vastness of Earth's beginnings, into the drifting silence of dust and the stellar wind. You find yourself returning to these journeys? Please consider liking the video, subscribing to the channel, or sharing it. And to those who've already joined along, thank you and welcome back, long before Earth takes form. Before seas or skies, there is only dust-enchant grains carried by the stellar winds of long-dead stars. They wander for eons in the cold dark between suns, fragments of supernova, of dying giants, of cosmic fires that burned out billions of years ago. Each grain is a relic, a memory of earlier worlds that never found balance. Tiny crystals of silicates drift alongside flecks of carbon soot, iron shards, and frozen ices. They are smaller than sand, yet hold in them the chemistry that will one day give rise to oceans, continents, even breath. This cloud does not stand still. Gravity whispers across it, a slow tug guiding particles inward. The cloud begins to contract. Drawn toward its own center, pressed together until pressure kindles a new star. The sun flares awake, light searing the darkness, wind streaming outward, shaping the surrounding cloud into order. Gas and dust flatten into a spinning disk. Thin veils spread across millions of kilometers. This is the beginning of the solar system, the stage upon which Earth will slowly emerge. Inside this swirling cradle, collisions are constant, though gentle at first. Dust clumps into larger grains, grains into pebbles, pebbles into stones. Collision carries both destruction and creations. Some fragments shatter, others fuse. The irony lies in the fragility. Worlds begin as fragile as powder, yet from this fragility will come mountains and oceans. Another irony, so much chaos and violence, and yet the outcome is steady, ordered rotation around a new star. A third, irony rests in scale itself. An entire planet to be begins with matter too small to see, yet too enduring to erase. The star's light grows stronger, driving gas outward, leaving heavier elements behind. The building blocks of rock and metal stay close, while lighter gases drift far into the outer reaches. Already, the architecture of planets is being drawn in silence, giants forming at the edges. Small, rocky worlds near the center. Dust pulled into spirals, moves in currents like rivers. An endless circulation. Among these currents, there are mysteries still unsolved. Why did Earth accrete where it did, balanced in just the right orbit for liquid water? Why did the cloud distribute matter unevenly, favoring some regions over others? Did Jupiter's vast presence shield Earth from destruction, or did it shape the violence that gave Earth its character? The answers remain uncertain, hidden in patterns of turbulence too complex to retrace. In this slow, patient unfolding, one sees the seeds of failure everywhere. Countless grains never bind. Countless planetesimals fall inward and vanish into the sun. The vast majority of material will never cohere into worlds at all. And yet, in one narrow belt of this disk, dust continues to gather, a faint hint of the world that will someday cradle seas, forests, and thought. Here, at the beginning, the universe is quiet, but never still. What seems like stillness is motion stretched across time, too vast for human senses. What feels like emptiness is fullness beyond measure, every grain carrying memory of a star long gone. In this drifting of dust, the foundations of Earth are being written not quickly, not deliberately, but as part of a rhythm that has no hurry, no pause, no end. The disk continues to turn. A wide and delicate veil of matter surrounding the young sun. Light falls across it in shifting bands, glinting off mineral grains that spiral like rivers within a current. Gas moves more swiftly than dust, pushed by solar winds, shaping eddies and vortices where pebbles gather. Each motion is unhurried, yet relentless. A choreography that repeats for millions of years. Within these spirals, collisions grow more frequent. Pebbles nudge together and stick, their surfaces rough with microscopic fractures, surfaces softened by frost and dust. Aggregates grow large enough to feel their own pull, each fragment held by the faintest gravity, each sphere of stone drawing more toward itself. These are the first planetesimal silent bodies no larger than mountains, yet already carrying the potential of entire worlds. They wander within the disk like seeds drifting in water, meeting by chance, breaking, fusing, beginning again. Irony lingers. Growth depends not on perfection, but on breakage. Each shatter exposes new surfaces that allow sticking. Each failure creates the possibility of new union. It is a quiet reminder that even a planet is born through countless failed attempts. A second irony appears in the scale of patience: millions of years for objects no larger than hills to gather, yet this is only a blink in cosmic time. A third irony rests in their fate: most will never grow, destined instead to be swept aside. Their existence forgotten within larger bodies. Heat becomes a companion to growth. As these planetesimals collide, the energy of their impacts releases as warmth, slowly melting interiors, allowing heavy metals to sink and lighter minerals to rise. In this process lies the first quiet differentiation, a subtle ordering of matter. Already, even in these small beginnings, the architecture of future cores and mantles takes form, yet mystery shadows the process. The precise role of turbulence in guiding this growth is still debated. Did vortices in the gas shepherd particles together, creating nurseries for worlds? Or was growth slower, a near-random sequence of stick and scatter across vast expanses? The record is hidden, erased by later collisions and absorptions. What is known is only the outcome. From dust, through pebble, to stone, a pathway emerges. These early bodies whisper of fragility. Their surfaces are bombarded by sunlight and wind, their orbits easily perturbed by larger neighbors. Many fall into the sun, many more are broken apart, scattering once again as grains. Failure dominates the scene, yet within failure lies persistence. Some endure, growing larger, crossing thresholds where their own gravity reshapes them into spheres. The disk thins as time stretches forward. Gas disperses into interstellar space, leaving behind rocks, metals, and ice. Within this quieter field, collisions now carry more consequence. What was once a pebble world becomes a protoplanet, an embryo of Earth. Heat builds within it. The gentle red glow of molten stone begins to replace the cool dust of beginnings. The calm rhythm remains. The star burns steadily, its wind sculpting space, while within its orbit, matter falls together in silence. To the human mind, such time is unimaginable, but to the universe, it is simply one movement within an endless song. From this rotating disk, the second stage of Earth's long journey begins, steady and unbroken, as inevitable as the turning of the sky. Collisions grow louder in the silence of deep time. The disk that once shimmered with diffuse dust now brims with bodies larger, heavier, restless in their paths. These planetesimals wander in slow orbits, but gravity draws them together like rivers converging into lakes. Where paths cross, impacts reshape them, violent in energy, yet muted across the eons. Each collision, another note in the quiet construction of a world. Pebbles have become boulders. Boulders have become mountains. Adrift, and now some grow to hundreds of kilometers across. Gravity strengthens with their mass, pulling matter inward, sculpting them into spheres. Rock flows under pressure, smoothing edges, transforming jagged rubble into rounded forms. These protoplanets, embryos of worlds, circle the sun, jostling, colliding, and merging. Some will survive, others will vanish, absorbed by larger neighbors. The irony is unmissable. Countless bodies form, yet only a few remain. The solar system begins with abundance, but settles into scarcity. A second irony rests in the cost of growth. Each planet is built through the loss of many others, their fragments folded invisibly into a greater whole. A third lies in perspective. What seems catastrophic, a collision capable of melting stone, is in truth the gentle arithmetic of planet building. Heat pulses within these growing worlds. Accretion warms their interiors, while radioactive elements decay, releasing further energy. The young Earth 2B glows beneath a shroud of vapor, a molten sphere wrapped in fire. Its surface churns with oceans of magma, restless tides of liquid. rock. Heavy metals sink downward, forming a dense core of iron and nickel. Lighter silicates rise outward, shaping a mantle and crust. Already the differentiation that defines Earth is underway, even before seas or sky, yet uncertainties linger. How rapid was this growth? Did Earth reach its near-final size in only tens of millions of years? Or was its assembly slower, stretched across longer ages? Models differ, their conclusions shifting with each refinement. Evidence lies locked in isotopes, in the ratios of tungsten and hafnium, hints written in the chemistry of ancient rocks. Still, the story is incomplete, shadows of unknown detail, lingering in the glow of what is known. Around Earth, the protoplanets continue their dance. Some veer close, scattering in chaotic encounters, their orbits stretched into ellipses. Some spiral inward, lost to the sun. Others strike and vanish, their matter merging invisibly into the growing body. Each impact alters rotation, tilts axis, redistributes heat. Earth's spin lengthens, its orbit stabilizes, not by design, but by the sheer persistence of chance over time. The memory of failure fills the scene. Countless worlds collapse, some never cooling, others breaking apart, their remains reabsorbed. Even within success lies fragility. Earth grows not from a stable plan, but from accidents repeated until one outcome endures. The disk thins as the years drift forward, fewer fragments left to collide, fewer worlds left to fall, and so the quiet persists. The solar system, once a storm of dust, begins to settle. The sun shines across a field of growing planets there. Paths more stable now, their motions slower, less chaotic. Earth circles steadily, still molten, still raw, but already distinct, a survivor in a system where most did not endure. The young Earth glows, its surface restless with fire. Oceans of magma roll and churn, waves of molten stone rising and sinking in convection too slow for the eye yet relentless over time. The air above is not yet air as it will one day be. Instead, it is a dense, choking haze of vapor steam from boiling rock, gases freed from minerals, fragments of the primordial disk that have not yet escaped to space. Carbon dioxide, methane, ammonia, and sulfur swirl in veils, their heat held close by the fiery planet beneath. Every impact still matters. Stray planetesimals continue to fall, each strike unleashing energy enough to melt new seas of magma there. Shock waves reverberating through the young crust. Some deliver water locked in minerals, others carbon compounds, seeding what will later become oceans and life. The irony lies in this violence. What seems only destructive is quietly creative. Another irony rests in time itself. What feels like an endless storm of impacts is but the briefest opening chapter of Earth's long history. A third irony, the planet, glowing hot enough to melt iron, already carries within it the foundations of stability that will one day nurture life in the interior. Differentiation deepens. Heavy metals cascade downward, pulled by gravity to the center, forming an immense core. Around it, lighter silicate rock builds the mantle, fluid yet thick, a slow-moving sea of stone. Above, the earliest crust forms, fragile and temporary, broken again and again by impacts and rising plumes of heat. The planet is layered now, though the layering is hidden beneath constant change. Mysteries linger within this fiery world.
How
Quickly did the first crusts solidify. Was the mantle convecting in great rolling cells or in turbulent eddies that shifted unpredictably? Did water arrive primarily from the planetesimals that now rain down, or from deeper sources released? As the mantle cooled, the answers remain uncertain, recorded only in traces too subtle, too altered by later history to resolve completely. Yet the magma ocean, vast and radiant, is real enough. Its surface shifts like liquid glass, fountains of lava spraying upward, cooling and sinking again. Steam rises in plumes, condensing into droplets that cannot yet fall as rain. For the heat turns them back into vapor before they reach the ground. The sky glows dim red, not with sunset, but with the constant scattering of light through haze and dust. This is the Earth of beginnings. Harsh, it's unstable, yet filled with potential. The failed worlds nearby, Mercury scorched, Venus smothered. Mars cooling to fast, teach, follow their own path. Earth alone maintains the delicate balance of heat and water, of mass and orbit, that will sustain it through ages to come. It is no certainty, only the outcome of endless accidents that happened. Not to fail, and so the planet spins, glowing, wrapped in its shroud of vapor. In its stillness is motion. In its chaos is order waiting to emerge. What is molten will one day cool. What is hidden will one day surface. But for now, Earth breathes in fire and exhales in steam. A world still shaping itself from the fragments of stars. A larger shadow enters this fiery stage. Among the wandering protoplanets, one drifts close. A world nearly the size of Mars. Following an orbit that intersects Earth's path, the encounter is inevitable, the mathematics of gravity ensuring that in time they will collide. When they do, the young Earth shakes to its core. The smaller body strikes at a glancing angle, its crust and mantle torn apart, fragments scattering into orbit. For a brief moment, Earth itself is unmade, its surface molten once more, skies filled with vapor and dust. From this destruction, a new companion emerges. The debris thrown outward does not vanish into space. Instead, it gathers into a ring. Circling the planet, glowing with heat, a halo of shattered rock. Within that ring, pieces begin to coalesce, drawn together by their own gravity. Slowly, silently, the fragments form a sphere, the moon. What could have been ruin becomes a lasting partner, orbiting Earth even now. Ironies drift through this scene. The first, that an act of near destruction gives rise to stability, for the moon will steady Earth's rotation, preventing the wild tilts that could have made climate unlivable. The second, that without the moon, tides might never have shaped shorelines where life would later thrive. Yet the moon itself is only the remnant of catastrophic impact. The third, that while other planets hold many moons, Earth keeps just one, and it comes not from capture, but from its own body torn apart. Mystery remains in the details. Was the impacting body truly a single protoplanet, sometimes named They? Or was the collision less singular, a sequence of smaller impacts? Did Earth and Moon mix completely, or does the Moon still hold distinct traces of its parent? The isotopes of oxygen in lunar rocks mirror those of Earth too closely. A puzzle that still unsettles scientists. As Earth recovers, its rotation is faster, its days shorter, perhaps lasting only 6 hours. The Moon, closer than today, looms large in the sky. A glowing sphere of molten rock, tidal forces tugging violently at Earth's oceans of magma. Both bodies radiate heat into space, cooling slowly, surfaces hardening, though the scars of the collision remain written deep within. The presence of the Moon will ripple through all of Earth's history. Its pull will govern tides, its light will guide life, its mass will keep Earth's spin steady for billions of years. What begins in violence becomes a quiet partnership, lasting through every age to follow. And so Earth turns once more now. With a companion, spheres travel together around the sun, bound by gravity, shaped by impact. Reminders of how easily worlds can be undone, how even in undoing, something enduring can take form. Fire and rain arrive together. The Earth, still glowing with its molten seas, exhales steam in endless plumes. Gases erupt from volcanic vents, carbon dioxide, nitrogen, water vaporizing into the thick sky. Heat keeps them suspended, a shroud of mist that circles the world. At time measured not in hours or years, but in millions upon millions, allows the atmosphere to cool. Droplets begin to fall, touching the molten crust below, only to hiss and vanish in bursts of vapor. Rain meets fire, and the cycle repeats without rest. Gradually, the surface hardens. Lava plains cool enough to hold water, and rainfall collects in shallow depressions, dark pools shimmering with dissolved minerals. The irony here is plain. The same heat that first drove water skyward now allows it to settle, though only in fleeting moments before boiling again. Second irony. Every drop that falls is ancient, carried from stars long gone. yet it becomes new in touching earth. A third, rain, usually seen as gentle, is at this time a force of transformation, carving. The first outlines of rivers and rock not yet stable. Mysteries remain hidden in this mingling of water and fire. How quickly did the oceans begin to form? Did most of the water arrive from the planet's own mantle, released by volcanism? Or did icy comets deliver a portion of it from beyond? The isotopic ratios of hydrogen in today's seas suggest a mixture, but the exact balance is unresolved. In this uncertainty lingers the quiet possibility that Earth's oceans were not inevitable, but fragile, dependent on timing as much as chemistry. The rain does not stop. It falls for ages, a planet-spanning storm measured in millions of years. Clouds dim the sunlight, casting Earth in twilight hues. Lightning forks through the haze, striking pools of water, feeding reactions that will one day matter deeply. The ground hisses, cracks, and steams, yet slowly the balance shifts. Pools grow into lakes, lakes into seas, and seas begin to merge into basins vast enough to cradle the first oceans. Through it all, the earth exhales. Volcanoes spew basalt across the crust, shaping new land even as water wears it down. Steam rises, condenses, falls again. The atmosphere thickens, its pressure holding warmth, its gases shaping climate. There is no blue sky, yet only a reddish gloom, a haze dense enough to conceal the stars. But beneath the veil, the first cycle of fire and rain has begun its long work. Stone meets water, water meets stone, each changing the other. The planet is no longer only molten, it is layered, now with liquid as well. In this mingling of extremes lies the quiet promise of stability, and so Earth turns. Steaming, raining, cooling, erupting a restless sphere, beginning to hold its breath between fire and water. The balance is delicate, precarious, and easily lost. Yet for now, the rains fall, the crust holds, and the first oceans begin to gather. The rains continue, their patient rhythm shaping the surface until hollows in the cooling crust deepen into basins. Water gathered from countless drops fills these depressions, spreading outward into wide, dark seas. These are the first oceans of Earth, shimmering with dissolved minerals, their surfaces reflecting the dim red light that filters through. Haze of volcanic gases. Waves roll across them, though there are no winds yet to stir them strongly. Only the subtle pull of the newborn moon drawing tides against still-forming shores. Basalt lines the seafloor, a dense rock born from fire, its black surfaces rich with iron and magnesium. When water touches it, minerals leach outward, feeding the oceans with salts and metals. Iron dissolves into solution, invisible but plentiful, lending the waters a chemistry unlike anything found today. What appears lifeless is already preparing the stage for life. Another irony, seas that seem permanent are in fact fragile, held together only by the balance of atmosphere and temperature. A third, the oceans, so vast and dominant, cover most of Earth's surface, yet remain only a thin film compared to the bulk of the planet. Mystery flows quietly here as well. How quickly did the seas cover the Earth? Some argue that global oceans formed rapidly, within tens of millions of years, while others suggest a slower filling, interrupted by evaporation and impacts. The precise depth of those first waters is unknown. Were they shallow expanses dotted with islands, or deep basins stretching across the globe? The record has been eroded, subducted, and remade, leaving only fragments of ancient zircon crystals to whisper their testimony. Above the oceans, the sky remains opaque. Carbon dioxide and methane thicken the atmosphere, scattering sunlight into a reddish glow. The greenhouse effect keeps the surface warm enough for liquid water. Despite the faintness of the young sun, which shines at only about 70% of its current strength, this paradox, the faint young sun with warm oceans beneath, lingers unresolved, a reminder that Earth's climate balance has always been precarious. Within the oceans themselves, silence reigns. No fish dart, no plant swayingly. Mineral currents move, slow and steady, across the dark sea floor. Hydrothermal vents begin to crack open in some regions, releasing plumes of superheated water rich with metals and sulfides. These black smokers will one day nurture ecosystems, but for now, they simply add their chemistry to the growing seas. The oceans reflect what little light reaches them, their surfaces rippling beneath a heavy sky. Though lifeless for the moment, they are already a medium for change, evolved to dissolve gases, to circulate heat, to shape coastlines with patient erosion. They cradle Earth's heat and temper its cooling, binding together atmosphere, crust, and mantle in one continuous cycle. And so Earth spins beneath its veil of clouds, seas gathering, basins deepening, water and stone locked together in the first great balance. The oceans, once only vapor and promise, now exist in truth, their presence both delicate and immense. A thin layer of liquid possibility stretched across a young and restless world. Amid the vast basalt plains that make up the early crust, something lighter begins to rise. Heat from below pushes upward, melting mantle rock, allowing fragments less dense to float above the darker seafloor. These fragments are small, fragile, yet distinct. They are the first continental seeds, patches of felsic rock, pale in comparison to basalt, enriched in silica and aluminum. In their buoyancy lies the quiet beginning of continents. These rafts drift like islands, their margins lapped by mineral-rich seas. Rain continues to fall, leaching elements from their surfaces, washing sediments toward shorelines that are little more than jagged edges of cooling stone. Over time, these first continental pieces expand, fused together by repeated eruptions, and impacts reshaped by subduction where ocean crust dives beneath. The irony is gentle. Continents, which will one day seem permanent, begin as fragile slivers, so easily broken, yet destined to endure for billions of years. Another irony. The crust that floats above is born from melting below, a paradox of lightness carried upward by heat. A third. Though these fragments will one day host forests and civilizations, they now lie barren, untouched by any living form. Uncertainty lingers in their story. Exactly how the first continental crust formed remains debated. Did subduction zones already operate, recycling basalt into lighter granitic rock? Or did plumes of heat simply melt patches of crust from beneath, allowing buoyant magma to crystallize into granite-like material? The evidence is scant, preserved only in tiny zircons found in ancient rocks, some dated to over 4 billion years old. These crystals carry within them hints of continental crust, yet their origins remain enigmatic. The seas respond to these new surfaces. Waves crash against their edges, tides drawn by the moon etching lines upon their shores. Water erodes, rock into sand and clay, carrying sediments back into the deep. In this endless exchange between land and sea, the first cycles of weathering and deposition begin, a process that will, in time, alter atmosphere and climate. Above, the sky still glows heavy with greenhouse gases, its red haze filtering sunlight into dim warmth. Yet light reflects differently upon these new lands, paler than the basalt seas, casting glimmers across the oceans that break the monotony of dark surfaces. Small though they are, these continental seeds change the balance of Earth's appearance and eventually its chemistry. The irony of failure still hovers. Most of these first continental fragments will not last. They will be swallowed back into the mantle, remelted, remade. Only a few traces remain in Earth's oldest surviving rocks, like rare fossils of a planet still shaping itself. Principle endures once begun. Continents will continue to rise, break, and reform, each cycle giving Earth its distinctive surface, and so the young planet turns, its oceans dark and wide, scattered with rafts of light stone. They are the first outlines of land, the earliest hints of continents, fragile beginnings that foreshadow mountains, valleys, and coastlines yet to come. In this quiet balance of buoyant rock and heavy seas, Earth takes another step toward the world it will become. The sky above these first oceans is not yet blue. Instead, it hangs as a heavy dome of haze, thick with methane, carbon dioxide, sulfur dioxide, and nitrogen. Sunlight filters through in muted tones, casting a reddish or amber glow upon the seas below. To look upward in those days would be to see not open space, but a canopy of particles scattering light, veiling the stars, dimming the sun to a faint orb. This atmosphere shields and shapes the planet. Its greenhouse gases hold warmth close, countering the faint young sun, which still shines weaker than today. Without this blanket, the oceans might have frozen, the surface locked beneath global ice. The irony is subtle. What one day will be seen as a threat to stability is, at the beginning, the very condition that allows stability. A second irony, the gases that choke and conceal will one day nurture and protect. A third, the sky that appears. Eternal and fixed is in truth only a temporary balance of vapors. Destined to change again and again, the air is dense, heavy to breathe if breath existed. Lightning forks across its layers, energy flashing through compounds, sparking reactions that build more complex molecules. Raindrops fall through the haze, carrying dissolved carbon and sulfur, feeding the chemistry of the oceans. The water below takes in gases from the sky, absorbing carbon dioxide until seas grow acidic, dissolving minerals from basalt crust and carrying them into circulation. Mystery still surrounds this early air. Exactly how much methane filled the sky, how much carbon dioxide, how thick the hazal remain uncertain. Clues are carried in ancient rocks and isotopes preserved from 4 billion years past, yet they speak in fragments. Some evidence suggests a greenhouse atmosphere dense with methane. Other interpretations lean toward carbon dioxide. The details remain elusive, a reminder that even the air of Earth's youth is only partly known. The oceans respond in silence. Their surfaces mirror the dim reddish light, their depths mixing with gases from the air above and heat from the mantle below. Hydrothermal vents belch minerals into water already rich with dissolved elements. Remains plentiful, lending. The sea is a hidden potential that will one day leave marks in banded stone. But for now, there is only darkness and chemistry. No creatures breathe this air. No eyes gaze upon the sky. The atmosphere exists for itself, shifting slowly as volcanic eruptions feed it, as rainfall scrubs it, as chemical reactions on stone and sea reshape it, molecule by molecule. The veil thickens, thins, changes, never quite stable, yet always maintaining the fragile balance between fire and ocean. And so the planet turns, wrapped in its shroud of gases. The stars remain hidden, but beneath the haze, the earth endures. Its air both protection and mystery. It's a restless atmosphere that will define every stage of life to come. Beneath the heavy sky, within the dark oceans, chemistry begins to weave new patterns. Simple molecules, carbon dioxide, methane, ammonia drift in water, carried by currents. Stirred by heat from the crust below, lightning flashes through the atmosphere, its energy striking the seas, breaking bonds, forging new ones. Hydrothermal. Vents exhale warmth and minerals, their plumes laced with sulfides and metals, creating pockets where reactions may linger longer than in open water. In these places, molecules begin to link. Amino acids form, nucleotides assemble. Simple building blocks gather on the surfaces of clays and minerals, where textures hold them in place long enough for patterns to emerge. It is not life yet, but it is something more than chemistry alone complex. Structures, self-replicating sequences, the earliest whispers of organization. The irony is quiet but sharp. What will one day be fragile cells, dependent on balance and stability, begins in the midst of heat, lightning, and acid seas. Another irony. Molecules that care nothing for survival arrange themselves into patterns that will one day struggle to survive. A third. The simplest beginnings are also the most difficult to reproduce in laboratories today, as though Earth guarded its first steps with secrecy. Mysteries remain vast here. Where, precisely, did life originate? Was it at the surface, sparked by sunlight and storms, or in the deep, nurtured by hydrothermal vents? Did clay minerals guide the assembly of nucleic acids, or did lipid membranes form spontaneously, offering compartments for chemistry to concentrate? Each hypothesis holds weight, yet none tells the full story. What is certain is that life arose. Early traces appear in rocks over 3.5 billion years old. suggesting that chemistry found its path almost as soon as oceans existed. The seas themselves become laboratories. Dissolved iron provides endless reactants, while tides stirred by the young moon circulate molecules across shorelines and pools. Evaporation concentrates them, rain dilutes them, cycles repeat endlessly. Overspans too vast to measure, chance and persistence shape order from disorder above. The atmosphere watches in silence, its haze dimming the light but not erasing it. Sunlight filters down, not yet nourishing, but still adding energy to the restless seas. Volcanoes erupt, adding new gases, altering the chemistry again and again. Earth becomes a planet in flux. Every surface, a place for reactions to test their endurance. And so, quiet, unseen corners, the first threads of life's possibility are woven. They are invisible, fragile, easily broken, yet endlessly attempted. Most fail, dissolving back into the sea. But some endure long enough to replicate, to persist, to leave faint marks on stone that will last for billions of years. The young planet turns. Oceans restless, atmosphere thick, chemistry alive with potential. Life is not yet certain, not inevitable, but the possibility now exists, whispered into being by fire, water, and time. Fragile beginnings take root in the shadows of deep time. Simple organisms, if they can yet be called that, cling to the edge between chemistry and persistence. In the oceans, molecules copy themselves, imperfectly, but often enough that patterns continue. Small compartments form, perhaps of lipid films, holding reactions within fragile boundaries. These are not yet cells as they will one day be, but they are the first structures to endure longer than chance alone. Survival here is paradoxical. Conditions are harsh. Oceans acidic with carbon dioxide, skies heavy with methane, volcanic eruptions constant. Yet it is within this instability that the earliest life finds its foothold. The irony is quiet. Stability, which will later be essential, begins in chaos. Another irony, though life now begins to shape the planet, it is also entirely at the mercy of the planet's whims. A third irony rests in scale. What will one day transform continents and climates is invisible. No larger than a film across a rock, evidence from stromatolite-slayered mounds left behind by microbial mats suggests that by 3.5 billion years ago, life is present in recognizable form. These structures, found in ancient sediments, cord communities of microbes trapping and binding grains of sediment, slowly building upward toward light. Yet uncertainty lingers. Are these true biological formations, or could some be mimicked by abiotic processes? Debate continues, for the record is faint. Altered by heat and pressure across billions of years, the chemistry of these organisms is simple yet profound. Metabolism emerges. Some microbes feed on sulfur, others on hydrogen, others still on simple reactions with minerals in the crust. No oxygen yet fills the air, only trace whispers within seas. But life persists, adapting to conditions that would extinguish most modern forms. The oceans play their part in silence. They mix nutrients, carry microbes across shorelines, cycle elements between surface and depth. Hydrothermal vents offer refuges rich in chemistry, while shallow tidal pools provide moments of concentration. Drying and refilling with each lunar cycle, in these spaces, persistence outweighs chance. Mysteries deepen with time. How rapidly did life diversify once it began? Was there a single origin, or multiple experiments, only one of which endured? Genetic evidence points to a last universal, common ancestor, a microbe from which all later life descends. Yet whether it was the only lineage, or merely the survivor of many, is unknown. And so the irony of fragility endures. Life begins not as a certainty, but as a narrow thread woven through chance, chemistry, and time. It survives not because the planet is gentle, but because within its harshness, there is room enough to persist. The earth turns slowly, its oceans carrying the faint signatures of life, its skies still heavy with haze. What was once only chemistry is now something more, though fragile, impermanent, and still without voice. Yet from this beginning, the story of survival stretches forward, unbroken across billions of years. Beyond Earth's seas, other worlds linger in silence. Mars, smaller and quicker to cool, holds valleys where water once ran, but its atmosphere slips away. It's carried off by solar winds after its magnetic field fades. Rivers dry, oceans vanish, leaving behind only faint scars upon red stone. Venus, nearly Earth's twin in size, turns instead toward heat. Its thickening atmosphere traps sunlight, water vanishes into vapor, and clouds of sulfuric acid swirl. Above an inferno of stone, where Earth begins to nurture oceans, its neighbors diverge into failure. The irony is simple, yet striking. 3 worlds begin with similar elements, yet only one holds liquid seas for billions of years. Another irony: Earth is not the largest, nor the most centrally placed, yet it alone balances between freezing and burning. A third: what will one day seem inevitable, that Earth carries. Life depends on accidents that denied the same chance to its siblings. Mysteries still surround their differences. Did Mars once harbor life before it froze? Did Venus lose its oceans in a runaway greenhouse that could easily have been Earth's fate? Models suggest possibilities, but certainty remains distant, for the records of those worlds are obscured. Mars preserves a frozen past, while Venus hides its surface beneath thick clouds and crushing air. Their lessons remain partly veiled, revealed only in fragments from orbiters and rovers. Meanwhile, Earth endures. Its magnetic field shields it from the sun's winds, holding atmosphere in place. Its balance of greenhouse gases remains enough to prevent freezing, but not so much as to trigger runaway heating. Tides stir its seas, volcanic eruptions recycle elements, and life continues to find its foothold in waters still warm and mineral-rich. The contrast with its neighbors emphasizes fragility. Earth is not guaranteed survival. It's one outcome among many, no more secure than Venus or Mars at the beginning. Yet, through chance and balance, it remains habitable, holding steady where others collapse. The skies above Earth are still dim with haze, but within its oceans life clings and multiplies. Stromatolite mounds slowly build, microbes continue. To feed the chemistry of persistence unfolds, while Mars cools into silence and Venus smothers beneath its clouds. Earth turns in rhythm, its oceans intact, its air retained, story still moving forward. And so, in the company of failed worlds, Earth holds its fragile course. Neither inevitable nor permanent, it remains habitable, carrying within its oceans the seeds of futures yet to come. Within the oceans, traces of life grow more visible, though still microscopic, still without eyes or voices. In shallow waters, along volcanic shores, mats of microbes spread, clinging to stone, binding grains of sediment together. Layer upon layer, they build low mounds, stromatolites. Their forms shaped not by intention, but by the slow repetition of growth and entrapment. These layered structures rise millimeter by millimeter, so slowly that a single hand's breadth may take centuries. Yet across millions of years, they leave monuments of life's earliest persistence. The irony lies in their modesty. The most enduring structures of early Earth are built not by great forces of geology, but by tiny organisms too small to see. Another irony: while mountains rise and vanish through tectonics, these microbial mounds survive in rocks billions of years old, more permanent than peaks of stone. A third: what today seems rare in exotic living stromatolites in a few shallow bases. And these ages, one of the most common signatures of life on Earth, their record appears in ancient rocks of Australia, South Africa, and Greenland, so more than 3.4 billion years old. These fossils of activity are not perfect, but their shapes and chemical traces point to life at work. The debate lingers. Could some structures be non-biological, products of mineral precipitation alone? The mystery persists, but the weight of evidence suggests that microbes were present, their colonies already shaping the planet. Their influence is subtle but profound. Through photosynthesis, certain microbes begin releasing oxygen as a byproduct, though the atmosphere does not yet record it. Oceans absorb this oxygen instantly as dissolved iron binds it, forming rust that settles to the seafloor.
Like the sky.
remains heavy with methane and carbon dioxide, but beneath the waves, chemistry is shifting in ways that will echo through billions of years. Stromatolite communities thrive in the shallows, exposed to sunlight, yet protected by water. They cycle with the tides, submerged and revealed in endless rhythm, building new layers while old ones compact into stone. Their activity is slow, almost invisible in the moment, yet in time, it alters both ocean chemistry and atmosphere. Above, the planet remains harsh. Volcanoes erupt, lightning flashes, the haze of methane filters light into amber tones. But in these quiet colonies, life persists. Its forms are humble, its process is repetitive, but its presence marks a threshold crossed. Earth is no longer only chemistry, no longer only rock and sea. It is a living world, even if its life is fragile, simple, and rare. And so, the oceans cradle these microbial builders. Their layered mounds rising slowly, their traces lasting longer than the continents themselves. In their stillness, the first architecture of life begins, not monumental in scale, but monumental in endurance. In the dim shallows where stromatolite mats thicken, an invisible process unfolds. Microbes capture sunlight, splitting water, weaving energy into chemical bonds. Their waste is oxygen, colorless, tasteless, unseen. At first it bubbles away unnoticed, dissolving into the mineral-heavy seas. Iron, abundant in the early ocean, seizes this oxygen greedily, oxidizing into rust that sinks to the seafloor. For millions of years, oxygen remains locked in stone, layered in bands of iron that will one day glint red in sunlight when raised into mountains. Here lies the first irony: oxygen, which will one day fill lungs and fuel fire, begins as a pollutant, an unwanted byproduct of microbial metabolism. A second, the most transformative gas in Earth's history, accumulates not in the air, but hidden away in rock, unseen by any living thing. Third, life seeking only to persist, unknowingly alters the entire chemistry of the planet. The evidence remains in banded iron formations, vast deposits of hematite and magnetite, their layers alternating light and dark, a silent archive of the ocean's invisible transformations. These rocks, billions of years old, are still quarried today, carrying within them the memory of Earth's earliest oxygen. Yet uncertainties linger. Did oxygen rise steadily, or in bursts? Were early oceans fully mixed, or were there isolated pockets where oxygen first built up? So the record is incomplete, altered by time and heat, leaving only fragments of the truth above the oceans. The atmosphere remains unchanged. Methane and carbon dioxide still dominate, giving the sky its reddish haze. Oxygen does not yet collect in the air, for the seas absorb it too quickly. The world remains anoxic, inhospitable to future forms of life. Even as its chemistry shifts quietly below the surface, in shallow waters, microbial mats continue their work. Each cell captures light, each colony builds structure, each cycle adds another layer of trapped sediment. Together, they alter oceans molecule by molecule, leaving behind both stone and chemistry as their record. They act without intention, without awareness, yet the consequences of their persistence will reshape every corner of the planet. And so, in the silence of deep time, oxygen begins its long ascent, not yet breathable, not yet free in the air, but present, accumulating slowly in oceans and rocks. It is the beginning of a transformation unseen, a change that will take billions of years, altering Earth from a world of haze to one of sky. The quiet release of oxygen, once hidden in stone, begins to reach a threshold. Oceans, long hungry for the gas, grow saturated. Iron no longer binds it as quickly. Minerals have already fallen in vast rust-colored layers to the sea floor. At bases end of bases. At bases end of bases. At bases end of bases. The way they said the way they said the way they said they said the way they said the. Minerals of low said cells and seds their lows. Minerals have already fallen in cellars. Rescend as well as cellars. at bull cells. The way of the well cells low. Well. So as well sellers ever poured, so off cells ever out. So seller out, aware. Band with sell well sell with so and sell all with and low wall sell with us sell without by a lot of soul sell all with us with sellers. Last, oxygen begins to escape the waters, drifting upward into the air. Slowly, molecule by molecule, the atmosphere itself changes. This transformation is known as the Great Oxygenation Event, and it unfolds not in moments but in ages. Over hundreds of millions of years, the sky begins to shift, its haze thinning. As methane reacts with oxygen, breaking down into carbon dioxide and water vapor, the balance alters, greenhouse gases diminish, sunlight changes hue. For the first time, the possibility of a blue sky emerges, though not yet fully clear. The ironies are striking. Oxygen, once poison to most microbes, will eventually become the very breath of larger life. Another irony: the waste product of the simplest organisms becomes the foundation of complexity. A third: life nearly destroys itself for the oxygen that fills the atmosphere, wipes out many ancient lineages unable to survive its reactive power. The record remains in stone. Banded iron formations give way to red bed sediments stained with iron oxides formed in air rather than ocean. These rocks mark the slow rise of oxygen in the atmosphere, their rusted hues a signature of the world's changing breath. Yet, uncertainty remains. Was the rise smooth or punctuated? Did oxygen first accumulate in isolated oases before spreading globally? Was it a single event or a series of pulses? The details are hidden, blurred by time, but the overall transformation is clear. As methane declines, climate begins to change. Greenhouse warmth weakens, and Earth tips toward colder conditions. Ice creeps outward from the poles, glaciers advance, perhaps even reaching near the equator. It is a paradox born of life. Microbes warm the world with methane, then cool it by replacing methane with oxygen. In their persistence, they alter not only chemistry but climate, reshaping oceans and continents. Alike, through it all, the microbial mats continue. Stromatolites grow layer upon layer, oblivious to the planetary upheaval their waste has caused. The seas remain rich with single-celled life, but much of it suffers, driven to extinction by oxygen's rising tide. Survivors adapt, finding ways to detoxify or even use the gas, setting the stage for new forms of metabolism, and so Earth turns. Its air no longer the same, its oceans no longer as they were. The great oxygenation has begun, a transformation slow yet absolute. Carrying the planet away from its first atmosphere and into a future forever altered, ice begins to spread. As oxygen reshapes the atmosphere, methane diminishes, and with it, the greenhouse warmth that once held Earth's surface in balance. The young sun still shines faintly, weaker than it will in ages to come, and without the full strength of methane, the warmth escapes. Glaciers advance, pale and silent, reflecting more sunlight away. White grows across the continents, across shallow seas, creeping ever closer to the equator. This is the onset of Snowball Earth, a time when ice may have sealed the oceans from pole to tropic. Sheets of frozen water stretch outward, kilometers thick, their weight pressing down on the crust. Beneath the ice, oceans remain liquid, warmed faintly by geothermal heat, but the surface is locked in stillness. Life continues, small and hidden. Confined to vents and oases where liquid persists, yet the planet as a whole lies under a cold silence. The irony is sharp. Oxygen, which one day will make great animals possible, begins by driving the planet into deep freeze. Another irony: water, the very medium that sustains life, becomes its greatest barrier when locked as ice. A third: the Earth, so recently shrouded in fiery haze, now rests under blankets of frozen clarity. Mysteries remain unresolved. Was the entire planet covered in ice? Or did bands of open water endure near the equator, refuges for life? How many times did these global freezes occur? Once, twice, or several times across the Proterozoic? Evidence lies in dropstones and glacial deposits preserved in ancient rocks, yet interpretation varies. The precise rhythm of these frozen ages remains uncertain. A puzzle still pieced together from fragments. The oceans beneath the ice remain restless. Hydrothermal vents still spew warmth and minerals into their depths. Microbes adapt, feeding on sulfur and iron, persisting in places where sunlight cannot reach. In darkness, life endures, unchanged in its simplicity, yet resilient in its persistence. Above, the ice reflects light into space, a feedback that deepens the cold. The planet becomes a mirror, bright and silent, drifting through its orbit. Volcanic. Eruptions still break through the ice in places, their plumes staining the atmosphere with carbon dioxide. But the cold persists for millions of years, and yet this frozen stillness is not the end. Beneath the ice, volcanic activity continues, releasing greenhouse gases slowly into the air. With no rain or weathering to draw them down, they accumulate molecule by molecule, building a future warmth that will one day melt the planet free. 4. Now, Earth remains locked in its icy silence. Glaciers stretch across the horizon, oceans lie hidden, and life survives in shadows. What seems like extinction is instead a pause, a long breath held before the thaw. Beneath the frozen stillness, volcanoes continue their quiet work. Magma rises through fractures, eruptions spread basalt across the hidden crust, and each plume of fire releases carbon dioxide into the air above the ice. Normally, rains and rivers would draw this gas back down, locking it into stone. But with Earth sealed beneath white, the cycle pauses. Weathering slows, chemical sinks vanish, and the atmosphere begins to gather greenhouse gases without balance. For millions of years, the buildup continues. Invisible molecules accumulate, their heat-trapping power growing even while the planet's surface remains silent under glaciers. Eventually, the balance tips. Sunlight, once reflected by ice, is now held more firmly by carbon dioxide. Warming spreads, slowly at first, then with momentum. Glaciers begin to melt at their edges, oceans rise to touch the air again, and the long freeze begins to break. The ironies unfold quietly. The first, volcanoes so often seen as destructive, become the agents of release, thawing a planet locked in stillness. The second, the very same gases that once threatened suffocating warmth, now rescue Earth from deep freeze. The third, what nearly ended life becomes the condition for its continuation. Evidence of this thaw remains, in cap carbonates thick. Layers of carbonate rock deposited as oceans reawaken, their chemistry shifting rapidly under the new warmth. These layers cap glacial deposits in the rock record, a geological signature of sudden transition. Yet uncertainties linger. How long did the ice ages last? Did the thaw come in pulses or in a single sweep? Were oceans fully frozen, or did bands of water endure throughout? The record speaks, but in fragments, leaving mysteries unresolved. As ice recedes, oceans return to open air. Waves move freely again, tides roll under the pull of the moon, and shorelines reshape beneath flowing rivers. Atmosphere thickens with carbon dioxide, warmer now than before, greenhouse power overcompensating for the freeze. For a time, Earth swings from one extreme to another, cold to heat, silence to motion. Through it all, life persists. Microbes, once confined to vents and small refuges, spread outward again, recolonizing seas, binding sediments, altering chemistry. Their persistence through glaciation is itself an irony. Life, though fragile in form, proves resilient across extremes that reshape the entire planet, and so Earth turns. Freed from its icy stillness, oceans once again under open sky, from fire, and gas balance returns. Not perfect, not permanent, but enough for life to continue. What seemed like the end is revealed as only another transformation in the long rhythm of a restless world. With the thaw comes new possibility. Oceans, now open to air, circulate more deeply, stirring nutrients that had lain trapped beneath ice. Microbes expand again across the seas, their mats spreading, their metabolisms diversifying. Within some of these single-celled organisms, a profound change begins. Nuclei form compartments within the cell where DNA is gathered, protected, and organized. This is the rise of eukaryotes, a new architecture of life. The appearance of these complex cells is not sudden, but gradual, scattered across millions of years. Fossil evidence is sparse, seen in rare microfossils preserved in shales and chemical traces that suggest sterols and other eukaryotic molecules. Yet by around 2 billion years ago, their presence is certain. Life has taken a step toward complexity that will one day allow multicellularity. Tissues and organisms beyond the scale of single cells. The irony is gentle. Eukaryotes are larger, more intricate, yet slower to reproduce, and thus seem at first less competitive than bacteria. Another irony: complexity, which will dominate in time, begins as a minority. It's fragile against the sheer abundance of simpler life. A third: what will become the foundation of animals and plants originates in an ocean still ruled by microbes invisible to the eye. Mystery lingers in their origin. Did eukaryotes arise once, in a single lineage that spread and diversified, or multiple times in parallel? What ecological pressures drove cells to internalize DNA, to separate chemistry into compartments? Some clues point to symbiosis, others to the need for greater efficiency, but certainty remains distant. The transition is one of biology's deepest enigmas, its details hidden in vanished ages. Inside these cells, mitochondria appear small structures that provide energy with remarkable efficiency. They, too, hold DNA, suggesting they were once free-living bacteria absorbed into larger hosts. The partnership becomes permanent, a fusion of lineages that grants eukaryotes new power. From this union comes the energy budget that will one day support multicellular life, forests, animals, and thought. The oceans shift around them. Oxygen, though still low, accumulates more than before, supporting metabolisms that rely on it. Eukaryotes adapt to niches bacteria alone cannot fill, colonizing shallows, spreading into varied environments. Their presence does not erase simpler forms. Prokaryotes remain dominant in number, but it sets the stage for a future where complexity will flourish. Above, the sky grows clearer, with less methane, more carbon dioxide, and increasing oxygen. Sunlight begins to scatter into blue. The world looks different now, though no eyes yet exist to see it. The irony is that the sky's transformation precedes vision, beauty that goes unobserved for hundreds of millions of years, and so Earth turns its oceans alive not only with the smallest cells, but with larger, more intricate ones that carry within them the seeds of all future forms. The rise of eukaryotes marks a quiet threshold, change invisible to the planet at large, but profound in its consequence, a new kind of cell, carrying forward the potential for all that will follow. Within the oceans, the story of complexity deepens. Some eukaryotic cells, already carrying nuclei and internal membranes, enter into partnerships with others. Bacteria are engulfed, but not digested, their presence tolerated within the host. In time, the relationship grows permanent. These internal partners become mitochondria, small powerhouses that provide energy far beyond what a lone cell could achieve. With this gift of symbiosis, eukaryotes gain efficiency, stability, the capacity to grow larger. The irony lies in the arrangement. What begins as an act of consumption becomes cooperation. Another irony: mitochondria, once free-living. Organisms now exist only within hosts, yet they grant their hosts the strength to diversify. A third: life achieves its greatest step toward complexity not through independence, but through surrender. This union is more than a detail. It is a turning point. With mitochondria, eukaryotic cells can sustain more DNA, more proteins, more intricate structures. Energy no longer constrains size in the same way. Cells branch into varied forms, some adopting cilia for motion, others expanding membranes to capture food. Multicellularity, though still far off, becomes possible because individual cells carry within them more power than ever before. Mysteries surround this moment. Was the partnership a singular event from which all mitochondria descend, Or did similar mergers occur multiple times? Why did this particular symbiosis endure when others surely failed? Genetic evidence suggests a single origin, a rare accident, that reshaped all of life to come. Yet the details, the exact lineage of the host, the ecological pressures, the setting remain unresolved. A fragment of history lost in deep time. Other symbioses follow. Some eukaryotes absorb cyanobacteria, which continue to photosynthesize within their hosts, eventually becoming chloroplasts. This second partnership gives rise to algae and later plants. Here again, life advances not through conquest, but through alliance. The oceans reflect the change. Microbial mats still dominate, but diversity expands. New lineages move into niches unfilled before, grazing, preying, competing, cooperating. The ecological web grows more intricate, even if still invisible to the naked eye. Above the atmosphere continues its transformation. Oxygen rises slowly, its concentration fluctuating, sometimes enough to fuel complexity, sometimes sinking again. These oscillations may have tested life, pruning some lineages, favoring others able to endure shifting conditions. Each fluctuation leaves traces and isotopes preserved in stone. But the full rhythm remains uncertain. The Earth turns quietly. Its surface little changed to the eye, yet within its oceans, life has crossed another threshold. Cells now carry others within them, not as intruders, but as companions. Energy flows more freely, possibilities widen, and the groundwork for multicellular organisms is laid. In this partnership, this quiet act of endurance and surrender, life finds its strength. The path to forests, animals, and thought begins. Here in cells that choose not destruction, but coexistence. The surface of Earth is never still. Beneath oceans and continents, mantle rock drifts slowly, carrying the crust upon its currents. Over millions of years, these movements shift entire landmasses, drawing them together, breaking them apart, raising mountains, and swallowing them back into the mantle. In this restless circulation, continents are not fixed, but wandering rafts. Upon a flowing sea of stone, already, the earliest continental seeds begin to drift. Some collide, fusing into larger landmasses. Others fracture, carried in opposite directions. At their boundaries, volcanoes rise, arcs of islands form, and mountains lift into the sky. Yet these mountains erode as quickly as they rise, worn down by rains and tides, their sediments carried back into oceans, recycled again into new rock. The irony is quiet but firm. Mountains, symbols of permanence, exist only as momentary expressions of balance. Another irony. The continents that will one day seem like anchors of stability are themselves only travelers across time. The third. The shapes of today's land masses, so familiar, are accidents of motion that will never repeat. Evidence of these ancient motions lies in cratons cores of continental crust that have survived billions of years. They carry scars of collisions and traces of vanished mountains, fragments of supercontinents long lost, yet the full history is uncertain. Did plate tectonics operate as it does today, with subduction zones and spreading ridges, or was early Earth governed by different mechanisms, hotter, faster, more chaotic? The record is incomplete, altered by metamorphism, buried beneath younger rock. What remains is only a shadow of the earliest continental dance. Still, the effects ripple outward. The movement of plates reshapes ocean basins, altering circulation, stirring nutrients that feed microbial seas. Volcanism releases gases into the air, maintaining balances of carbon dioxide and oxygen. Continents create shallow seas along their margins, new habitats where stromatolites thrive and eukaryotes expand. The geology of motion and the biology of life intertwine, inseparable from one another above. The sky carries more oxygen than before, though still far less than in modern times. Its pale blue deepens slowly, scattering sunlight more clearly, though no eyes yet exist to see it. The irony lingers. The world becomes more vivid, yet it remains unseen, and so Earth continues its patient shifting. Continents drift like rafts across oceans, collide to raise mountains, erode back into the sea, and reform again. The cycle repeats, unhurried, without end. Each movement setting the stage for climates, ecosystems, and futures still to come. The oceans grow restless with change. After billions of years of microbial dominion, life begins to diversify more suddenly. Around 541 million years ago, the Cambrian bloom arrives unfolding not in days, but across millions of years, yet still rapid in the scale of geology. Fossils become clearer in the record, shells and skeletons preserving shapes that were once invisible. Life discovers hard parts, and with them, new possibilities. Trilobites crawl across seafloors, their segmented bodies armored in calcite. Worms burrow into sediments, leaving trails of disturbance where once the mud lay smooth. Sponges, corals, and brachiopods anchor themselves, filtering water, building reefs. In the open seas, tiny creatures drift, planktonic forms that spread widely, feeding and being fed upon. The web of life grows denser, more intricate. Ecosystems no longer built only from microbes, but from visible, mobile, and varied organisms. The ironies of this bloom are quiet but striking. The first, the explosion of diversity depends on oxygen. Once poison, now a fuel for new metabolisms. The second, the hard shells that protect creatures also ensure their visibility to the fossil record. So survival and memory become entangled. The third, what seems like a sudden beginning is, in truth, the unveiling of processes that have been building silently for eons. Mysteries persist. Why here? Why then? Was it oxygen finally reaching a threshold? Or ecological feedback's predators? Driving prey toward new defenses. Prey driving predators toward new strategies. Did genetic innovations, like the rise of Hox genes, open pathways for new body plans? Fossils reveal the result, but the precise triggers remain debated. A puzzle, left partly unsolved. The oceans themselves change in response. Currents circulate more deeply. Nutrients rise from seafloors to feed plankton blooms. Reefs begin to grow more complex, creating habitats where diversity flourishes. Seafloors, once marked only by microbial mats, now carry the imprints of shells, trails, and burrows. Above, the continents continue to drift, their erosion feeding the seas with minerals. Shallow continental shelves expand, offering broad areas where sunlight reaches the seafloor. These new spaces become laboratories for life, or environments rich with both resources and challenges. And so Earth turns, its oceans no longer silent, but filled with movement, its stone no longer recording only chemistry, but the shapes of bodies. The Cambrian bloom is not a sudden event, but a threshold crossed, a new rhythm added to the planet's unfolding song. Life is visible now, varied and enduring, its traces preserved in stone for all the ages to come. As the Cambrian bloom unfolds, oceans begin to breathe more deeply. Currents circulate oxygen into waters that were once stagnant, carrying it downward into seafloors that had lain in darkness for ages. With this change, ecosystems spread, no longer confined to shallow shores alone. The deep ocean, once limited to microbes and chemical cycles, begins to host more complex life. Fossil beds reveal this shift. Creatures with skeletons and shells scatter across sediments, leaving their imprints preserved in stone. Trilobites range widely, their remains found on every ancient continent. Echinoderms, ancestors of starfish, anchor to the seabed. Filter feeders flourish, drawing nutrients from water now stirred and replenished, once only chemical, become biological engines, cycling not only carbon and sulfur, but also energy through intricate food webs. The ironies remain steady. The first, oxygen, a waste of early microbes, now supports creatures that in turn reshape the seas where those microbes once ruled. The second, diversity spreads not in silence, but in feeding and predation. Life thrives by consuming life. Third, abundance brings vulnerability. For ecosystems more complex are also more easily disrupted. Mystery lingers in the patterns of circulation. What triggered the oxygenation of deeper waters? Was it tectonic motion, continents drifting too? Alter currents, or the gradual rise of oxygen in the air? Evidence points to multiple causes, but no single explanation holds all the weight. What is clear is the outcome. Oceans that once suffocated with anoxia now breathe more freely, opening new ecological spaces. On the seafloor, burrowing animals alter sediments, mixing layers, oxygenating muds, breaking apart the stability of microbial mats. This bioturbation reshapes ecosystems as much as oxygen itself, changing chemistry, reshaping habitats, and making room for new forms. Life becomes both engineer and inhabitant of its environment, reshaping the very ground upon which it lives. Above, continents erode under rainfall and wind, their minerals washed into seas. Nutrients feed plankton blooms, which in turn feed larger creatures, weaving food webs of increasing complexity. Reefs rise taller, carbonate structures built by countless small organisms, creating walls and labyrinths where others find shelter. The oceans glitter beneath a sky more open, more blue, sunlight scattering more clearly now that oxygen is present. Yet no eyes as we know them see this full clarity, only the simple lenses of trilobites, jellyfish, and worms. The irony is that beauty exists unobserved, its patterns of light and sea awaiting senses still to come, and so Earth turns its oceans, alive with circulation and life, its waters breathing more deeply than ever before. The planet, once shaped only by stone and chemistry, now reshapes itself through biology as well. In this mingling of oxygen, current, and life, Earth becomes not only a world of matter, but of motion and interaction without end. Life reaches upward from the water. On shorelines where tides rise and fall, small plants begin to colonize damp stone. Their bodies are simple, little more than filaments and mats, yet they hold within them the capacity to anchor, to root into the land itself. By the middle of the Paleozoic, plants have gained strength enough to spread across continents, carpeting lowlands, climbing upward in forests, shaping the air and soil. Roots dig downward, fracturing stone, prying apart cracks, releasing minerals into rivers and streams. In their quiet persistence, these roots begin the long process of making soil, a surface that had never existed before. Rain mixes with organic matter, forming fertile ground. The irony rests here. Land, once lifeless and barren, becomes a place of growth because of organisms too small and simple to be noticed in their time. Another irony. Forests so solid and enduring to the eye are built on the slow crumbling of stone. A third. In seeking stability by rooting themselves. Plants create change more dramatic than almost any other lineage. The mystery of timing remains. Fossil spores suggest that plants began their journey onto land more than 450 million years ago, yet the exact steps are blurred. Did algae first creep onto mudflats, surviving only at the margins before evolving vascular tissues? Did fungi assist them, forming the earliest symbioses that allowed roots to take hold? The details remain partly hidden, recorded in fragments of spores, stems, and impressions in ancient shales. As forests spread, the atmosphere responds. Photosynthesis draws in carbon dioxide, releasing oxygen in exchange. Levels of oxygen climb higher than ever before, fueling metabolisms and reshaping climate. Carbon drawn into soils and buried in sediments reduces greenhouse gases, allowing glaciers to advance again in cycles. The breath of forests becomes the breath of the planet, their exhalations altering climate on a scale as vast as volcanism once had. Continents feel their presence too. Vast lowlands transform into swamps, their soils thick with roots and fallen leaves. River systems wind through forests, their channels shifting with the guidance of vegetation. Hills erode more quickly under the pull of roots and rain. Land and life become inseparable, each altering the other above. The sky deepens into a clearer blue, sunlight scattering through an atmosphere richer in oxygen. Forests rise into this light, their canopies forming shadows across the ground, their leaves swaying in winds that carry pollen, spores, and seeds, and so Earth turns. Continents no longer barren but clothed in green, roots binding stone leaves. Reaching skyward, forests weaving oxygen into air. In their stillness, plants reshape everything, their quiet persistence altering atmosphere. Soil, rivers, and climate, preparing the stage for animals yet to come. As forests spread across continents, another quiet transformation unfolds. In swampy lowlands and broad river valleys, dense vegetation grows in profusion, layer upon layer of leaves, stems, and roots falling into dark waters. Oxygen-poor conditions, slow decay, allowing carbon to accumulate in thick mats of peat. Over millions of years, as sediments bury these swamps, pressure and heat compress the organic matter into seams of coal. The earth begins to lock away vast amounts of carbon, storing in stone the breath of ancient forests. The ironies here are patient. The first, the lushness of forests, teeming with growth, becomes fuel for ages far beyond their own. The remains burned by humans hundreds of millions of years later. The second, by drawing carbon into the ground, forests help cool the planet, setting in motion ice ages that challenge the very ecosystems that created them. The third, what feels like permanence towering trees, endless swamps becomes fragile. When their own success reshapes climate against them, geological evidence records these cycles. Coal seams stretch across continents, marking intervals when vegetation flourished. While glacial deposits interrupt them, reminders of cooling triggered in part by carbon burial. The balance of carbon dioxide, once governed mostly by volcanism, and weathering now shifts under the influence of life itself. In this, biology and geology become entwined, inseparable in their feedbacks. Mystery persists in the details. How extensive were these forests, and how evenly did their burial reshape atmosphere? Did fungi capable of breaking down lignantha? Complex, would polymer exist yet? Or did their absence allow wood to accumulate more rapidly into coal? Fossil fungi suggest their evolution came later, perhaps explaining why carboniferous forests left behind such abundant seams. Insects and amphibians thrive in these swamps, their bodies growing larger under oxygen-rich air. Dragonflies span half a meter across. Millipedes lengthen into creatures as long as humans. Yet the forests themselves remain the main actors, pulling carbon downward, releasing oxygen skyward, altering balance with every season of growth. Above, the sky holds more oxygen than at almost any other time in Earth's history, perhaps exceeding 30%. Fires rage more easily, sparked by lightning, their flames consuming dry vegetation, feeding yet another cycle of carbon to atmosphere and soil. Forests both give and take, their presence stabilizing climate, yet their abundance also carrying risks of collapse. And so Earth turns, its continents cloaked in swamps, its atmosphere reshaped by trees and roots, its crust storing carbon in seams of coal that stretch across deep time. What began as simple mats of algae now blankets continents and forests, changing not only the surface, but the very chemistry of the world itself. Life flourishes, yet flourishing is never without cost. Every expansion of forests, reefs, and swamps, there comes a contraction, a time when abundance is swept away. Extinctions mark the record like quiet interruptions, not always sudden, but absolute in their finality. Species that once thrived vanish, leaving no descendants their forms, preserved only in stone. Volcanism often plays a role. Great eruptions pour basalt across continents, releasing gases that thicken or thin the atmosphere. Carbon dioxide warms, sulfur dioxide cools, each altering balance, sometimes together, creating climates unstable for life. Impacts from space also arrive sudden and without warning, striking oceans or continents, lifting dust into skies. Darkening sunlight for years, sea levels rise and fall as tectonics shift continents, drowning habitats or stranding them inland. In each case, ecosystems collapse not from malice or design, but from the indifference of Earth's motions. The irony is gentle but stark. Life, so adaptive and persistent, depends on stability that the planet never guarantees. Another irony, extinction clears the way for diversification, loss becoming a precondition for renewal. Third, species that endure for millions of years appear eternal, yet their time is always finite. Measured against the slow rhythms of climate and crust, Mysteries remain in the details of each loss. Was the late Devonian extinction, for instance, triggered by the spread of forests themselves, their roots drawing nutrients into oceans, fueling anoxia that suffocated marine life? Was it volcanism, or cooling, or some combination of all? The rock record suggests causes, but disentangling them is elusive, for events overlap, signals blur, and time compresses what were once vast ages. Through these extinctions, life never vanishes entirely. Microbes endure in every condition, from boiling vents to frozen soils. In the seas, survivors persist, rebuilding ecosystems after each collapse. On land, plants return, though often in altered forms, adapted to climates reshaped by crisis. Extinction is both an end and a reset, a rhythm as old as life itself. Above, the sky remains indifferent. Oxygen and carbon dioxide fluctuate, but the planet turns steadily. Seasons follow. Tides roll. From afar, nothing seems amiss, yet within the oceans, reefs vanish. Upon land, forests retreat. Life's presence thins, only to expand again in time. And so Earth continues, extinctions marking pauses within abundance, absences shaping futures as much as presences. The irony is that failure species lost, ecosystems broken, becomes the condition through which new forms arise. Each extinction leaving space for life to begin again. After silence, recovery begins. Extinctions, empty oceans, and forests. Yet, they do not erase the capacity for renewal. Survivors endure, scattered across niches left vacant, adapting to altered climates, slowly multiplying once more. Over millions of years, ecosystems rebuild, not as replicas of what was lost, but as new arrangements of species and forms. The Earth, patient as ever, gives time for diversity to return in the seas. Corals and sponges reclaim space on reefs, constructing new frameworks from calcium carbonate. Fish diversify, exploring shapes and strategies that will carry them into future ages. On land, plants expand again, their roots binding soils, their canopies shading wetlands, their spores and seeds finding purchase where forests had retreated. Amphibians spread along riverbanks. Reptiles begin to appear, their scaly skin better suited for drier conditions. The web of life weaves itself back together, strand by strand, until abundance reappears. Ironies ripple through this renewal. The first, what seems like permanent loss becomes the condition for innovation. New lineages rising where old ones fell. The second, ecosystems, though fragile in the moment, reveal strength across time, repairing themselves with patience no single species can perceive. The third, what humans will one day call stability, is in truth only the pause between extinctions and recoveries. Mysteries remain in the rhythm of this return. Why do some groups diversify rapidly after collapse, while others linger in low diversity? For millions of years, is recovery driven by ecological opportunity, by genetic innovation, or simply by the passing of time? Fossil records reveal patterns, yet the mechanisms remain partly obscured. Blurred by the slowness of the process, during these recoveries, Earth's surface also changes. Continents drift, mountains rise and erode, seas advance and retreat. Geological shift creates new habitats, offering platforms for life to occupy. Tectonics and biology intertwine. The lifting of a mountain range creates rivers. The opening of an ocean basin circulates nutrients, each shaping evolution as much as genetics itself. Above, the sky continues its cycles. Oxygen levels fluctuate, sometimes rising, sometimes falling. Sometimes limiting the size and vigor of animals, sometimes allowing them to grow larger. Carbon dioxide drifts upward with volcanism, downward with burial of organic matter, its balance forever shifting. These atmospheric rhythms guide recovery as much as the biology itself, and so Earth turns. Extinctions fading into recoveries, recoveries building into new diversities. What was broken is not restored, but reimagined. From each silence comes a different song, from each collapse, a new flourishing. Life, fragile in the moment, proves resilient across ages. Its persistence measured not in centuries, but in billions of years. Reptiles rise from the margins of recovery, their bodies suited for land in ways amphibians could not match. Scales hold in moisture, resisting the drying heat of the sun. Eggs encased in protective shells develop on land rather than in water, freeing these creatures from dependence on rivers and swamps. With these quiet innovations, reptiles spread across the continents, moving into forests, plains, and deserts, their steps measured against the slow shifting of Earth itself. The irony rests in their simplicity. A thin layer of keratin, a harder shell, and life crosses a threshold that reshapes ecosystems. Another irony, the fragile egg, so small and exposed, carries within it the independence that allows reptiles to colonize new worlds. The third, amphibians, once the pioneers of land, remain bound to water, while reptiles arriving later make the land fully theirs. The fossil record preserves their early forms. Small, lizard-like creatures with sprawling gaits, their tracks pressed into mud that hardened into stone. Over time, lineages diversify, some growing larger, armored with plates and spines. Others slender and swift, adapted for pursuit or concealment. Each lineage explores a different solution to the challenges of terrestrial life. Mystery shadows their beginnings. Exactly how quickly reptiles radiated from their amphibian ancestors remains uncertain. Their fossils scattered and incomplete. Did climate pressures favor their rise as swamps dried and forests receded? Or was it ecological opportunity, new niches left open after extinctions? The truth likely lies in both, woven together by chance and persistence. On the continents, reptiles reshape the web of life. They prey upon insects that once dominated forests, upon amphibians still bound to water. They themselves fall prey to larger reptiles and, in time, to one another. Predation and defense grow more intricate. Shells and teeth, claws and armor, each innovation met by another in return. The land itself responds. Vegetation continues to spread, roots binding soils, rivers meandering through plains, deserts stretching. Where rainfall fails, reptiles adapt to each environment, their scales reflecting sunlight, their metabolisms tied to warmth, their bodies crafted by climates that change slowly yet ceaselessly. Above, the atmosphere holds oxygen at high levels, fueling energy for both plants and animals. Fires sweep across dry forests, recycling nutrients, shaping ecosystems. Skies clear blue, an oxygen-rich light, winds carrying spores, seeds, and the movements of creatures across continents. And so Earth turns, reptiles now part of its living mantle, stepping across land once barren, thriving where others could not. Their rise marks a threshold as profound as forests before them. Another quiet transformation in which small changes yield vast consequence. Life, through scales and shells, claims the continents more fully, shaping worlds within worlds upon the restless face of stone. The continents do not remain scattered. Slow currents within the mantle draw them together, inch by inch, until collisions forge a single vast landmass Pangaea. By the late Paleozoic, nearly all Earth's continental crust lies fused into this supercontinent, stretching from pole to pole, surrounded by the immense Panthalassic Ocean. Its interior is harsh. Far from coasts, rainfall seldom reaches, and vast deserts spread beneath a searing sun. Forests retreat to the margins, clinging to rivers and shorelines, while inland plains lie dry, cracked, and windswept. The irony is quiet. The greatest landmass in Earth's history contains within it some of the most lifeless expanses. Another irony, seas, though endless, are pushed to the edges, leaving the heart of Pangaea starved of water. A third, unification, which might suggest stability, instead creates extremes of climate. Vulnerability within Mensed confirm its breadth. Mountain chains, such as the Appalachians and Urals, mark the scars of continental collisions, raised high. As crust buckled under pressure, sediments preserved deserts of red sandstone, dune fields once swept by relentless winds, coal deposits rich with the remains of swamp forests. edge its margins, reminders of lushness confined to the coasts. Yet uncertainties linger. How uniform was Pangaea's climate? Did monsoons sweep across its edges while interiors baked in? Drought. Did atmospheric carbon dioxide swing widely with the rise and fall of forests? Fossil distributions suggest varied climates, but the details remain incomplete. Reconstructed only in fragments of stone and isotope. Life adapts to these conditions. Reptiles thrive in the arid expanses, their scales conserving water, their eggs sheltered from desiccation. Amphibians linger in wetter refuges, constrained by their need for moisture. Insects diversify further, some growing enormous and oxygen-rich air, others filling niches in forests and deserts alike. Oceans, too, feel Pangaea's presence. With a single supercontinent, currents shift, circulation patterns reorganize, altering the distribution of heat and nutrients. Coastal ecosystems flourish, but open oceans become more stratified, at times starved of oxygen in their depths. These fluctuations ripple through marine life, shaping extinctions and recoveries above. The sky remains oxygen-rich, yet carbon dioxide fluctuates with volcanism and burial. Periods of cooling bring glaciations, even while deserts spread in. Warmer intervals. Climate is not steady but oscillates, testing ecosystems on both land and sea. And so Earth turns with Pangaea at its center. A single supercontinent vast and extreme, binding together lands that will one day separate again. Its existence is temporary, its immensity fragile against the slow pull of mantle currents. Yet in its time it reshapes climate, oceans, and life itself, leaving scars and legacies that endure long after its break. The unity of Pangaea does not last without upheaval. Deep within the mantle, plumes of heat rise, pushing at the crust. Rifts spread, cracks open, and magma surges upward in volumes immense beyond measure. Basalt floods pour across the land, covering millions of square kilometers in black stone, their flows stacking layer upon layer, thick enough to bury mountains. With each eruption comes gas. Carbon dioxide streams into the air, its greenhouse. Power tipping the climate toward heat. Sulfur dioxide joins it, reflecting sunlight in the short term, but soon dissolving into acid rains that scar soil and stone. The irony rests in this rhythm. Eruptions that darken skies with cooling particles also warm the earth in the long span. Another irony, stone, which seems inert, becomes the agent of atmosphere, exhaling gases that alter oceans and air. A third, continents so solid to the eye, prove fragile under the slow persistence of mantle plumes. These outpourings, known as flood basalts, leave scars preserved even today. The Siberian traps, the Deccan traps, vast plateaus of basalt, mark ancient episodes of fire. Their scale is beyond modern comparison, their volumes measured not in single eruptions, but in centuries and millennia of continuous outflow. The Earth, through these events, reshapes its own surface in floods of molten stone. Mystery lingers in their timing. Did the release of gases occur gradually, or in sudden bursts? How closely were these eruptions tied to mass extinctions that followed? The evidence suggests connection, yet cause and effect blur. The sequence preserved imperfectly in rock layers. As carbon dioxide rises, oceans absorb it, becoming acidic. Their chemistry shifts, shells dissolve more icily, reefs weaken. Currents falter as temperatures alter circulation. Oxygen decreases in deep waters. Anoxia spreading through basins, once rich with life. On land, warming drives forests into decline. Drought spreads across interiors. And ecosystems falter above. Skies fill with haze. Ash and aerosols dim sunlight, turning days into twilight, nights into deeper cold. Only for greenhouse gases to rebound with longer warming. The climate swings, unstable, harsh, unforgiving. And so Earth turns under the breath of basalt floods, its crust reshaped, its atmosphere unsettled. These outpourings are reminders that geology and life remain bound together, that continents and oceans cannot remain separate from the gases that rise from fire. In their silence, these eruptions alter the course of life, setting the stage for collapse, yet also for renewal. As the planet continues its unending rhythm of change, from fire comes silence. Around 252 million years ago, as vast basalt floods erupt across what is now Siberia, the Earth undergoes its greatest recorded crisis. Gases rise in volumes too great to balance. Carbon dioxide thickens the air, oceans. Warm circulation weakens. Oxygen falls from the depths. Hydrogen sulfide blooms in anoxic waters, spreading poison into seas and atmosphere alike. Life, abundant and diverse, falters on nearly every front. In this event, the Great Dying, over 90% of marine species vanish. Coral reefs collapse. Trilobites, present since the Cambrian, disappear entirely. On land, forests thin, insects decline, reptiles and amphibians wither in shrinking habitats. Entire lineages vanish, their continuity broken, their fossils marking an abrupt and final end. The ironies are stark. The first, what life had built across hundreds of millions of years, is undone in a span geologically brief, a few million years at most. The second, extinction, which clears space for innovation, here nearly empties the stage, leaving little to continue. The third, a planet that appears stable in its immensity, proves as fragile as any of its inhabitants. The causes remain debated. Flood basalts of the Siberian traps release gases, but how swiftly and in what sequence? Did methane, frozen in seafloor sediments, escape, amplifying warming? Did ozone collapse under chemical assault, exposing land life to ultraviolet radiation? The evidence suggests layers of catastrophe, each reinforcing the other, yet the precise pathways remain uncertain. In the oceans, warming halts circulation, stagnant waters lose oxygen, anoxia spreads, and with it hydrogen sulfide, a gas lethal to most organisms. Once confined to seafloor sediments, it rises into open waters, suffocating marine life. On land, heat and drought parch interiors, while acid rains scar forests. Ecosystems that survived smaller extinctions now collapse in full, yet not all vanishes. A few lineages persist: small reptiles, burrowing forms, microbial mats that thrive even in toxic waters. These survivors carry the thread of life forward. Even as the planet seems emptied, above, skies swing between haze and brightness. Volcanism continuing for hundreds of thousands of years. Carbon dioxide remains high. Greenhouse heat lingers. Recovery delayed by the persistence of gas in the air. The silence of extinction is not immediate, but stretched. A long pause before life can begin again. And so Earth turns under the shadow of the Great Dying. Its surface scarred, its oceans depleted, its forests gone. The fragility of abundance is revealed, the impermanence of lineages laid bare. Yet even here in the greatest silence, the planet holds survivors, and from them the next chapters will be written. In the wake of silence, patience becomes the rhythm of Earth. The Great Dying leaves ecosystems bare, their intricate webs torn apart, their connections broken. Recovery is not swift. It unfolds across millions of years, slower than forests grow, slower than reefs build, slower even than continents drift. Tracing fragile paths through the emptiness, small reptiles creep into niches once crowded with diversity. Burrowers find safety in the soil, escaping heat and drought. In the seas, bivalves and ammonoids survive, their shells modest compared to the vanished trilobites, yet resilient enough to carry forward. Microbial mats return in places, reclaiming space once occupied by reefs. From these modest survivors, new lineages branch, slow radiations filling the gaps left by extinction. The ironies are steady. The first, what nearly ended life entirely, becomes the seedbed of new forms, absence giving way to presence. The second, survivors, often small and overlooked, inherit the earth, while the grand and dominant vanish. The third, ecosystems that feel timeless are revealed as fragile, rebuilt again and again across deep time. Mystery lies in the pace of recovery. Fossil evidence suggests millions of years passed before ecosystems reached even partial stability. Is the delay caused by continued volcanism, greenhouse heat, or poisoned oceans? Did diversity rebound slowly because climate remained unstable? Or simply because life needs time to explore new possibilities? The causes remain uncertain, the story pieced together from scattered rocks and fossils on land. The first new forests return only gradually, their roots binding thin soils, their canopies sparse compared to earlier swamps. Insects recover more quickly, buzzing through ferns and cycads, feeding reptiles that adapt to new diets and climates. In the seas, reefs take far longer to return, their absence marking one of the slowest recoveries in Earth's history. Above, the atmosphere holds high carbon dioxide, keeping climates hot, monsoons heavy, and deserts expansive. Skies remain blue, but their brightness carries heat that shapes every ecosystem below. Earth feels emptied, yet alive, suspended between collapse and renewal. And so Earth turns. The silence after extinction giving way, slowly, to the persistence of survivors. What seems an end proves only another transition, though stretched across spans so long that even resilience appears fragile. In the patience of recovery, life reveals its endurance, reweaving what was lost, creating patterns that will one day flourish again. As recovery deepens, reptiles grow in scale and variety. From the survivors of the Great Dying, new lineages branch into forms that dominate land, sea, and air for more than 160 million years. These are the dinosaurs, though their reign includes far more than the great names that will one day be remembered. They begin as small, agile creatures, but soon diversify into herds of herbivores, swift predators, soaring pterosaurs, and marine reptiles vast enough to rival whales, forests of conifers, cycads, and ginkgos spread across the continents, providing food and shelter. Herbivorous dinosaurs graze in herds, reshaping landscapes as they move. Carnivores follow, their teeth and claws adapted to each prey. In the oceans, ichthyosaurs and plesiosaurs thrive, their bodies sleek for swimming. Their young born live in water. Above, pterosaurs spread wings of skin and muscle, taking to the skies for the first time among vertebrates. The ironies of this age ripple softly. The first, the Great Dying, which nearly erased life, clears the stage for dinosaurs to rise, absence, giving way to abundance. The second, creatures so immense, seemingly invincible, exist only because of the fragility of those who came before. The third, their dominance measured in millions upon millions of years, will one day vanish in an instant. Mysteries remain in their ascent. Why did dinosaurs succeed where other reptiles faltered? Was it chance, physiology, or climate? Their upright gait, efficient lungs, and rapid growth suggest advantages, but the full story resists simple answers. Fossils reveal detail, but not inevitability. During their reign, continents drift again. Pangea fractures, opening the Atlantic, reshaping. Currents, altering climates. Deserts shrink, coastlines multiply, and with them new habitats arise. Diversity expands with geography, ecosystems flourishing in isolation. Each continent carrying its own variations of reptilian life. Above, oxygen levels shift but remain supportive. Carbon dioxide higher than today, keeping climates warm and lush. Polar regions host forests, dinosaurs roaming under months of twilight, their bodies adapted to both heat and cold. The planet is fertile, abundant, and alive with forms of astonishing size. And so Earth turns through the long age of dinosaurs. Oceans stir with marine reptiles, skies ripple with wings, continents shake with the steps of herds. Life, once nearly extinguished, now thrives in forms that seem without limit. Yet even this abundance remains bound to time, fragile against the rhythms that will one day bring silence again. Amid the vast reign of reptiles, a quieter lineage begins its own ascent. Plants, which once clothed the continents in ferns, cycads, and towering conifers, now shift toward a new strategy. Flowers appear small at first, almost unremarkable, against the scale of forests, yet carrying within them a transformation as profound as the rise of dinosaurs themselves, angiosperms. The flowering plants evolve structures to attract pollinators, offering nectar or pollen in exchange for movement of genetic material. Their petals, colors, and scents arise not for beauty, but for efficiency, yet they will later reshape entire landscapes. Fruits develop, enclosing seeds and protective flesh, enticing animals to carry them farther. In their quiet invention, flowering plants diversify into forms more adaptable than almost any lineage before them. The ironies unfold with softness. The first, flowers, delicate and transient, outlast forests of stone-tall conifers in evolutionary success. The second, attraction, a strategy based on vulnerability, becomes one of the most enduring advantages in survival. The third, while dinosaurs dominate in size and spectacle, it is plants, with their small and fleeting blooms, that establish patterns lasting to the present. The mystery of their origin remains unresolved. Fossil flowers appear suddenly in the record during the early Cretaceous, already diverse, already widespread. Charles Darwin once called this abruptness an abominable mystery. Did they evolve earlier in small, unnoticed populations, or did conditions suddenly favor their expansion? The details are incomplete, but their impact is undeniable. With flowers come pollinators. Insects adapt to nectar and pollen. Bees and butterflies joining beetles and flies in complex relationships that bind plant and animal together. Coevolution accelerates each change in flower mirrored by change in insect, weaving networks of mutual dependence across ecosystems. Forests shift in composition. Where once conifers and cycads held dominance, angiosperms spread rapidly, filling every niche. Grasses and open plains, broadleaf trees in fertile valleys, vines climbing upward toward the canopy. Their flexibility reshapes habitats, providing food and shelter for a diversity of animals. Dinosaurs graze upon leaves and fruits, mammals nibble seeds, insects sip nectar, each bound into cycles of abundance that flow from flowers above. The atmosphere carries more oxygen than in earlier eras, feeding both reptiles and insects. Skies grow clearer, climates stable enough to sustain forests that stretch from tropics to poles. The world becomes greener, richer, more intricate, not through size or power, but through the delicate architecture of blooms. And so Earth turns. Its continents clothed in flowers, its air filled with pollinators, its ecosystems deepened by the subtle invention of petals and seeds. The age of dinosaurs remains in full stride, yet in the quiet unfolding of plants, another future takes root, enduring beyond reptiles, beyond even the age itself. Abundance deepens across the Cretaceous world. Dinosaurs roam in herds across fertile plains, forests thicken with flowering plants, insects swarm through blossoms, and seas teem with ammonites, fish, and marine reptiles. Life appears unstoppable, filling every corner of land, sea, and sky. Yet in this fullness lies a quiet irony. Stability itself becomes fragility. For ecosystems woven so tightly are vulnerable when even one thread is pulled. The first irony is simple. The very success of abundance creates dependence, each lineage bound to others in intricate ways. A second, diversity, which protects against extinction, also ensures that collapse spreads quickly when balance fails. A third, the most enduring pattern of life is impermanence, hidden within moments that feel eternal, evidence in the fossil record reveals ecosystems of extraordinary variety. Drosaurs graze on flowering plants, sauropods strip leaves from conifers, ceratopsians clash with horns and frills, and tyrannosaurs stalk the margins. In the seas, mosasaurs rule, ichthyosaurs fade, and new lineages of fish expand. Pterosaurs soar above, their wings spanning cliffs to valleys. Mammals remain small, nocturnal, their presence modest but persistent, yet mysteries remain in the balance. How did flowering plants rise so swiftly to dominance over conifers? Did their partnership with insects give them unmatched advantage? Or did climate shifts open the way for their spread? Why did some reptilian lineages flourish while others dwindled? The fossil record offers outlines, but never full certainty. Continents continue to drift, opening the Atlantic wider, raising mountains along new margins. Shallow seas flood interiors of continents, creating vast inland oceans rich with life. These marine expanses connect ecosystems, spreading species across distances once isolated, yet they also make the planet sensitive to sea level change. Each fluctuation, altering coastlines and habitats above, the atmosphere carries steady warmth, greenhouse gases higher than in later ages. Polar forests thrive under long twilight summers, reptiles and plants enduring months of dim light. The planet is warm enough to sustain life nearly everywhere, its abundance spread across latitudes, and so Earth turns through an age of plenty. Its biosphere rich, its continents green, its oceans alive with form. The irony remains, even in its greatest flourishing, life is no less fragile, no less bound to the rhythms of climate and stone. The age of dinosaurs continues, immense and intricate, yet always carried within the limits of time. The abundance does not last. 66 million years ago, a body from space approaches, a fragment of rock and metal more than 10 kilometers wide. It strikes the shallow seas near what is now the Yucatan Peninsula, releasing energy greater than billions of atomic bombs. In an instant, Earth is transformed. Shockwaves ripple through stone, tsunamis surge across oceans, forests ignite, and skies darken with dust and vapor. This is the impact winter. Sunlight, once steady, is blocked by the veil of particles hurled into the atmosphere. Photosynthesis falters, forests wither, oceans lose their plankton, food webs collapse from the base upward. Dinosaurs, vast and dominant for more than 160 million years, dwindle and vanish, leaving only their avian descendants to carry the lineage forward. The ironies are heavy. The first, creatures that endured countless shifts in climate and continents, fall to an event lasting only years. The second, the mightiest animals vanish, while the smallest birds, mammals, insects find ways to persist. The third, the very catastrophe that erases giants, opens space for others to rise. Absence becoming opportunity. Mystery persists around the details. Was the impact alone sufficient, or did it combine with massive volcanism in the Deccan Traps, which at the same time release carbon dioxide and sulfur into the air? Did ecosystems already strain before the collision, or were they flourishing? Until the instant of impact, the debate continues, the record bearing witness but not full clarity. The aftermath is stark. Forests thin to ash, oceans lose their great reptiles, ammonites disappear entirely. Survivors cling and refuges small. Mammals burrowing underground, birds feeding on seeds, crocodiles enduring in rivers, turtles in ponds. Microbes, as always, persist, unshaken by what overwhelms larger forms. Above, skies remain dim for months, perhaps years, before slowly clearing. Carbon dioxide from fires and volcanism lingers, warming the planet after its cold pause. Climates shift once more, reshaping landscapes. But now without the herds of dinosaurs that once shook the ground, and so Earth turns, silence replacing thunder. The age of dinosaurs ends not with decline, but with suddenness, their absence written in the break between rock layers. Yet life continues, small survivors carrying forward the story. In the shadow of catastrophe, the stage is cleared for new lineages, new dominions, new possibilities that will shape the Cenozoic world to come. In the silence left by the dinosaurs, small creatures stir. Mammals, long confined to shadows, begin to expand. For over 100 million years they had remained small, nocturnal, sativorous, hiding from predators beneath roots and in burrows. Now, with the great reptiles gone, niches open wide. Forests regrow, spreading across continents, and mammals diversify into forms that creep, climb, swim, and run. The irony is gentle but profound. The first, fragility, once a limitation, becomes survival for smallness, allows endurance when giants fall. The second, mammals, overlooked for ages, inherit a world they had no hand in clearing. The third, the very traits that once defined them as marginal nocturnal habits. Rapid reproduction, generalist diets, become advantages in the reshaping of ecosystems. Fossil evidence shows their expansion, rodent-like forms gnawing seeds. Primate ancestors leaping among branches, hoofed mammals browsing leaves. Carnivorous lineages sharpening teeth for pursuit. Within a few million years, diversity multiplies, filling every available role. Whales return to the seas, bats take to the skies, ungulates roam the plains. The descendants of survivors weave new ecosystems across land, sea, and air. Mystery remains in the timing. Did mammals already begin diversifying before the impact, poised to expand once dinosaurs fell? Or did the true radiation occur only afterward? Fossil records suggest hints of both, a pattern blurred by gaps in preservation. Genetic studies point to deep roots, yet the fossil record emphasizes sudden expansion. The truth may be both gradual and abrupt, layered together. Forests play their part, offering branches, fruits, and seeds to climbing primates and rodents. Grasslands emerge later, reshaping diets and forms, guiding evolution toward grazers and predators adapted to open plains. In each habitat, mammals adapt, their warm-blooded bodies and fur granting them freedom in climates that swing between heat and cold. Above, the atmosphere steadies. Oxygen levels hover near modern values while carbon dioxide falls to levels lower than much of earlier Earth, cooling climates, spreading ice to poles. Seasons sharpen, demanding further adaptation. Life resilient adjusts again, ecosystems reshaping under the rhythms of tectonics and air, and so Earth turns into its new age.
Ow.
No longer the world of reptiles, but one where mammals spread quietly, persistently diversifying in ways unseen before. The story carries forward not with sudden giants, but with steady expansion. Small survivors inheriting a planet emptied by catastrophe and filling it once more with motion and sound. Countenance. Drift toward shapes more familiar. The Atlantic Ocean widens, its mid-ocean ridge pushing seafloor outward in steady increments. Carrying the Americas away from Africa and Europe, India drifts northward, racing toward Asia, where its eventual collision will thrust the Himalayas skyward. Africa inches toward Europe, preparing to close the ancient Tethys Sea. Slowly, Earth's surface begins to resemble the map known today, though still in motion, never fixed. The irony rests in this slow transformation. The first coastlines that seem eternal are revealed as temporary outlines, shifting with the patience of stone. The second, mountains, symbols of permanence, rise only to erode, their debris carried to seas that will one day uplift again. Third, the continents that humans will one day name and know are not stable landmarks, but passing arrangements in a restless cycle. Geological evidence records each step. Magnetic stripes on the seafloor mark reversals of Earth's field, preserving the widening of the Atlantic. Fossil distributions confirm shifting connections. As lineages once united by land drift apart, their divergence written in evolution. Sediments capture rising mountains, their grains carried down rivers, building deltas at continental margins. Mysteries remain, particularly in the timing of deep processes. Why do mantle plumes arise where they do, lifting plateaus and splitting continents? Why do subduction zones sometimes stall, only to resume millions of years later? Plate tectonics explains the motion, but not always the rhythm, the hidden pulse. Of Earth's interior, the consequences ripple through ecosystems. New coastlines create shallow seas, fertile zones for marine life. Mountains alter climates, blocking winds, creating deserts on their leeward sides and forests where rains condense. Continents connect and separate, guiding migrations, isolating lineages, driving evolution. Above, climates cool gradually as carbon dioxide declines. Antarctica drifts toward the South Pole, its isolation by currents preparing the way for future ice sheets. In northern latitudes, forests adapt to seasonal extremes, growing hardy cones. preparing for colder rhythms still to come. And so Earth turns, its continents moving toward a configuration that appears stable only to those who measure time in centuries. Truth, the surface remains fluid, its features provisional, its outlines temporary. The familiar world takes shape, not as final form, but as one moment in an endless cycle of drifting stone. With continents drifting toward modern outlines, climates begin to pulse in new rhythms. Around 2.6 million years ago, great sheets of ice advance from the poles, spreading across northern continents, carving valleys, grinding mountains, and reshaping rivers. These are the ice ages, cycles of glaciation and retreat, driven by subtle shifts in Earth's orbit and tilt. By variations in how sunlight falls across latitudes, glaciers grow for tens of thousands of years, locking water into frozen mass, lowering sea levels by more than 100 meters. Coastlines stretch outward, continental shelves exposed as plains where grasses spread and animals roam. Then, as orbits shift again, the ice melts, seas rise, coastlines retreat, and valleys fill with rivers once more. The rhythm repeats, slow, unhurried, yet relentless. The ironies of ice are gentle. First cold, so often seen as absence, becomes a sculptor, carving landscapes that will endure long after the ice retreats. The second, hardship for life, creates opportunity. As shifting climates open corridors for migration, mixing lineages across continents. The third, the instability of glacial cycles produces the stability of ecosystems, adapted to change. Mysteries linger in the details. Why do glacial cycles intensify around 1 million years ago, their swings deeper and longer? Was it due to carbon, dioxide, feedbacks, the erosion of continents, or shifts in ocean circulation? The interplay of orbital mechanics and earthly feedbacks remains a puzzle. Partially understood, still studied in ice cores and sediments, the evidence of ice is written clearly across landscapes: U-shaped valleys, polished rock, moraines of stone, carried and left by glaciers. Fossil pollen, in sediments records, shifting forests, retreating and advancing with the ice. Loess plains, built from wind-blown silt, mark the dryness of glacial winds sweeping across exposed shelves. Life responds. With resilience, mammoths graze on cold grasses, woolly rhinoceroses move across steppes, saber-toothed cats hunt in frozen plains. In warmer interglacials, forests return, spreading across continents, supporting deer, horses, and smaller mammals. Humans, appearing late in these cycles, learn to adapt, following herds, finding shelter, controlling fire. Above, the atmosphere breathes with the ice. Carbon dioxide falls during glaciations, rises in interglacials, tracing a rhythm recorded in bubbles trapped. Within ice cores, the planet inhales and exhales across tens of thousands of years, climate tied to cycles beyond the span of lifetimes. And so Earth turns. Its surface shaped by ice, its seas rising and falling, its climates oscillating between warmth and cold. The rhythm is not an interruption, but part of the planet's deep song. Another movement in the endless interplay of stone, air, and life. Amid the pulsing of ice and thaw, a new lineage begins to walk the earth. On the African plains, hominins stand upright, their spines adjusting, pelvis narrowing, feet reshaping for long steps across open grasslands. Bipedalism frees the hands, which grasp tools of stone, simple flakes at first, then more refined edges. In this shift, a path unfolds that will one day carry humans across the globe. The irony is quiet but clear. The first, walking upright, an adaptation for endurance on. The savanna becomes the foundation for technologies that alter the entire planet. The second, fragile creatures with little natural armor survive not through strength but through cooperation and tools. The third, what begins as a minor change in gait becomes the pivot of Earth's future history. The fossil record preserves their presence. Australopithecus afarensis, known from bones pressed into sediments, shows long arms still suited to climbing, yet feet aligned for walking. Later, Homo habilis shaped stone into tools, evidence of thought carried in rock fragments scattered. Beside ancient camps, skulls expand slowly, cranial capacity increasing, though still far smaller than in modern humans. Mysteries remain. Why did upright walking arise when it did? Is it climate, as forests retreated and grasslands spread, or chance within small populations? Did tools follow walking, or did they co-evolve with changes in hand and mind? The answers remain incomplete. Debated across fragments of bone and stone, as hominins spread, they adapt to shifting climates of the Pleistocene. Glaciers advance and retreat, grasslands spread and shrink, rivers shift their courses. Populations migrate with herds, following water, moving into new valleys as old ones dry. Fire becomes a companion, first borrowed from natural blazes, later tended, warming shelters, extending daylight. Protecting from predators above, skies are the same blue that modern humans know, clouds drifting, stars visible at night. 2. Early hominins, these skies carry no words, no constellations, only light and darkness, storm and calm. Still, under them, minds awaken, perceptions sharpen, patterns begin to be remembered. And so, Earth turns, glaciers carving valleys, grasslands opening, forests shrinking and spreading again. On its surface, fragile creatures walk upright, carrying tools of stone, beginning a journey that will link biology to culture, survival to invention, in ways no other lineage has yet achieved. Fire becomes companion rather than only danger. At first, it is gathered from lightning strikes and volcanic flows. Embers carried carefully from one place to another, tended through the night. In time, early humans learned to kindle it themselves, striking stone against stone, coaxing sparks into flame. With fire, the rhythm of life changes. Nights grow longer in warmth and light, food softens in cooking, landscapes themselves are shaped by deliberate burns. The ironies of flame are quiet. The first, what once threatened survival becomes its foundation. The second, a force that destroys. Forests also nurture societies, clearing land, protecting against predators, warming bodies in glacial cold. The third, the simplest tool in ember. Spark carries within it the power to alter climates and continents. Archaeological traces remain faint but enduring. Charred bones, blackened stones, ash layers within caves all speak of fires tended hundreds of thousands of years ago. Hearths reveal circles where small groups gathered, sharing warmth, food, and perhaps the earliest forms of community beyond mere survival. Mystery lingers in the origins. When did humans first master fire fully, moving from borrowed flame to intentional ignition? Evidence suggests more than 1 million years ago, though certainty remains elusive. Different sites, scattered across Africa and Eurasia, preserve signs of fire use, but whether these mark true control or opportunistic gathering is debated. What is clear is that by several 100,000 years ago, humans relied on fire as an essential part of life. The consequences ripple outward. Cooking transforms diets, unlocking calories from roots and meats, shrinking the burden of chewing, reshaping jaws and teeth. Firelight extends the day, allowing activity in hours once confined to darkness. Smoke repels insects, shelters become warmer, migration into colder climates becomes possible. Forests and grasslands feel its touch. Deliberate burns clear undergrowth, encourage the growth of certain plants, and attract grazing animals. Landscapes begin to show the mark of intentional fire, ecosystems shifting subtly under human hands long before agriculture. Above, stars wheel unseen by flame, their patterns hidden by smoke and light, yet fire itself becomes a star of earth small. Flickering, held close, a sun drawn down into the circle of human life, and so earth turns. Its glaciers advancing and retreating, its climates shifting, while at its surface, humans gather around flame. In the quiet crackle of fire, a new rhythm begins, one that links survival to control of energy. Binding biology to culture in ways the planet has never known before. Step by step, humans move outward. From African valleys where upright walkers first gathered, Small groups follow rivers, coastlines, and open plains, carrying fire, tools, and memory. Glaciers advance and retreat, opening corridors, closing them again. Yet persistence carries them across deserts, mountains, and seas. Over tens of thousands of years, they spread into every continent except the frozen reaches of Antarctica. The ironies unfold softly. The first, a species without claws, fangs, or armor, becomes the most widespread mammal on Earth. The second, fragility, once a liability, turns to strength through cooperation, speech, and shared memory. The third, migration, born of necessity, becomes the defining pattern of a lineage that will one day cross even oceans without sight of land. Archaeological traces record the journey. Stone tools mark camps along ancient lake shores. Obsidian flakes carried far from their volcanic sources. Fossil footprints show paths of families moving together across volcanic ash. Caves preserve paintings of animals long vanished, outlines of hands pressed in pigment, signs of minds remembering more than survival alone. Mysteries linger. Exactly when did the first humans leave Africa, and in how many waves? Genetic evidence suggests multiple dispersals, some vanishing, others enduring, weaving a complex ancestry still studied today. Did migration follow coastlines rich in fish and shellfish, or inland rivers where herds grazed? The record suggests both, yet details remain unresolved. As humans spread, they meet new climates and landscapes. In Eurasia, they walk among mammoths and woolly rhinoceroses. In Australia, they adapt to arid deserts and coastal wetlands, reshaping ecosystems through fire. In the Americas, they cross land bridges, or perhaps even coasts, entering continents, filled with unfamiliar megafauna. In each place they adapt, shaping tools, language, and culture to match the world around them. Above, skies remain the same, stars wheeling in silence, seasons turning with orbital rhythms. Yet humans begin to name them, to carve meaning into constellations, to follow their patterns in navigation. The heavens become maps, guides, stories, markers for journeys across land and sea, and so Earth turns, carrying its newest wanderers across plains, forests, and coasts. In their persistence, humans knit together continents once isolated, carrying with them not only survival but memory, invention, and story. Migration becomes the quiet thread binding their history to the planets. Deep time, a pattern as old as rivers and as wide as oceans. With their spread across continents, humans begin to alter the balance of the world itself. Fire clears forests, herds are hunted, rivers are crossed with rafts and boats. Tools sharpen from stone to bone, from bone to metal, each step amplifying the reach of fragile hands. What was once adaptation becomes mastery, and mastery reshapes the earth. The ironies are quiet yet profound. The first, a species born vulnerable to cold and hunger, becomes the shaper of climates and landscapes. The second, in seeking survival, humans alter the very balances that sustain them. The third, mastery, which seems strength, is also fragility, for the power to change the planet is inseparable from the risk of undoing it. Evidence lies in sediments and soils. Charcoal fragments speak of fires set deliberately, reshaping ecosystems into grasslands. Bones of giant animals disappear from the record. Coinciding with the arrival of humans and new lands, mammoths, giant sloths, marsupial lions, all fading within a few thousand years. Lakes and deltas preserve pollen grains, their shifts recording. The retreat of forests where agriculture spreads. The signatures of humanity appear not only in tools and art, but in the chemistry of Earth itself. Mystery remains in timing and scale. Did humans alone drive the great extinctions of megafauna? Or did climate swings already weaken those populations? Did fire reshape entire continents, or only landscapes near settlements? The record reveals correlation, but disentangling cause is complex, woven from climate, chance, and choice. Meanwhile, cultures expand in diversity. In river valleys, agriculture begins, tying human life to soil, water, and seasons. Villages rise, then cities, then networks of trade. Metallurgy shapes bronze, then iron, then steel, each advancing the reach of human intention. With writing, memory extends beyond the mind, stored in clay, papyrus, and stone. With navigation, oceans are crossed, continents linked, boundaries erased above, the sky bears witness in silence. Stars that once guided hunters now guide sailors. Moons that once marked tides now mark calendars. The heavens remain unchanged, yet human eyes see them differently, carrying instruments that turn points of light into maps of the cosmos, and so Earth turns, carrying a species that is no longer only participant in its rhythms, but agent of change. Within them, humans born from the same accidents as microbes and reptiles now alter forests, rivers, climates, and oceans, writing themselves into the planet's story as both creation and disturbance. The irony lingers. Mastery is fragile, for it ties survival not only to nature's balance, but to choices made within it. As humans look upward, they begin to see that Earth is not alone. The night sky, once only a field of stars for navigation and story, becomes a map of other suns. With telescopes, faint points resolve into worlds. Jupiter's moons circling in steady rhythm, Saturn's rings glinting with icy fragments, Mars showing deserts where rivers once flowed. In time, instruments turn outward farther still, revealing planets beyond the solar system, orbiting distant stars by the thousands. The ironies emerge softly. The first. For most of history, Earth seemed singular, the only cradle of life. Yet observation now shows planets are common. The second, the discovery of abundance, emphasizes rarity. For though worlds are many, few seem suited to water and air. The third, by seeking elsewhere. Humans learn more deeply how fragile their own world is. Science detects these exoplanets in quiet ways. The dimming of starlight as planets pass before their stars, the tug of gravity shifting orbits, the faint signatures of atmospheres hidden in spectra. Some are giants like Jupiter, circling close and hot. Some are rocky, like Earth, orbiting within their star's habitable zone, where liquid water might exist. Yet distance keeps certainty elusive. They are shadows measured in data, their details inferred rather than seen. Mysteries remain profound. Do these planets hold oceans, atmospheres, perhaps even life? Or are they sterile stones, failed worlds like so many in our own solar system? Without direct exploration, answers remain beyond reach. The silence of the cosmos endures, broken only by the signals humans themselves send outward. Meanwhile, Earth itself offers context. Venus shows what happens when greenhouse gases overwhelm, turning a world into furnace. Mars, with its lost rivers and dry plains, shows the fragility of atmosphere. Gas giants reveal storms without end, ice giants their tilted seasons. Each world teaches by contrast, reminders that Earth's long balance is neither inevitable nor permanent. Above, the stars remain ancient and constant, though human eyes see them differently now. Each one becomes not only a point of light, but a potential system of worlds, each orbit a possibility. It's most lifeless, some still unknown. And so Earth turns, a singular planet among countless others. Its life carried not by inevitability, but by chance within the vastness. To wonder if it is alone is to recognize both its rarity and its fragility. A world sustained through balances that may not often repeat. In seeing other worlds, humans begin to reflect on their own. Earth, once thought infinite in its resilience, reveals limits. Ice cores record carbon dioxide rising faster than at any point in hundreds of thousands of years. Oceans absorb heat, expanding, currents shifting, reefs bleaching. Forests shrink beneath chainsaws and fire. The atmosphere, thin as breath compared to the planet below, holds more greenhouse gases than at any time in human history. The ironies settle gently. The first, mastery of fire, once survival, becomes risk as fossil fuels alter the sky itself. The second, the very abundance that humans create food, energy, cities presses against the systems that sustain them. The third, in reaching outward to study other planets, humans see most clearly the fragility of their own. Scientific records mark the changes with precision. Satellites measure the retreat of glaciers, the rise of seas, the shifting of seasons. Coral skeletons preserve chemical traces of warming waters. Tree rings show droughts deepening, forests stressed by heat. The Earth speaks in data as well as in stone, its message unambiguous, though responses remain uneven. Mystery lingers in. Outcomes. How far will seas rise? How quickly will ice sheets melt? How much can ecosystems adapt? Models trace possibilities, but feedbacks are complex. Methane released from thawing permafrost. Ocean currents slowed by melting ice, forests shifting from sinks to sources of carbon. The uncertainties lie not in whether change occurs, but in how far and how fast. Yet resilience is also written into the planet. Life has endured through ice ages, through mass extinctions, through volcanic winters and warming seas. The biosphere will persist, though its patterns may shift, its diversity altered. What remains uncertain is not Earth's survival, but the place of humans within its future balance. Above the skies remain blue, the stars steady beyond the haze. From orbit, Earth appears Hole's world with clouds, edged in thin atmosphere. Alive in ways no other planet yet observed can match. To see it this way is to recognize both its singularity and its fragility, suspended in silence within the cosmos. And so Earth turns, carrying the weight of human presence within its rhythms. The planet has survived greater changes, yet never before from one species alone. The story continues, as it always has, in patience and persistence. The outcome shaped not by inevitability, but by choices within the brief span of human time, through all ages, from molten beginnings to oceans and ice, from microbes to forests, from reptiles to humans. Earth has remained a singular thread woven through deep time. It is not the largest planet, nor the closest to its star. Yet here, conditions aligned, oceans held their water, atmosphere balanced its gases, continents drifted but did not vanish. Against all odds, life endured. The ironies are soft in conclusion. The first, abundance, which feels eternal, is only ever temporary, yet from each ending, life begins again. The second, fragility, which seems weakness, proves the essence of survival. For even microbes and shadows carry the thread forward. The third, Earth, which feels permanent beneath the feet, is revealed as transient in cosmic scale, its stability, both rare and precarious. Science still holds mysteries. How common is life elsewhere, among the countless planets now known? Why did Earth succeed where Mars and Venus failed? Did chance alone favor this world, or is the universe filled with others that simply remain unseen? The questions are open, their answers distant, perhaps unknowable, yet they linger, echoing with each discovery of another star, another orbit, another shadow of a world. And so Earth turns, still patient, still restless, carrying continents across mantle currents, glaciers across valleys, forests across soils. It is one planet among billions, yet for now, the only one known to hold rivers that flow, skies that breathe, and beings who wonder at their place within it. The story quiets now. No more collisions, no more extinctions, no more migrations, only stillness. Earth rests in its orbit, circling the sun as it has for billions of years, turning gently through day and night. Oceans sigh against their shores. Winds drift across forests and deserts. Glaciers gleam in silence at the poles. Time stretches wide here, beyond the span of memory, beyond the reach of history. Continents continue their drift, so slowly that even mountains seem motionless in the present. Rivers cut their valleys grain by grain. Deltas extend by inches into seas. Sands shift in deserts with winds unhurried. The rhythms of the planet move too slowly for urgency, yet they never cease. Above, the stars remain steady. Some have burned for billions of years. Others will burn billions more. Against their constancy, Earth appears brief, yet for those who walk upon it, its time feels endless. The thin blue atmosphere holds warmth and air, cradling life as softly as breath. In this stillness, the planet waits. Not for an ending, not for a purpose, but simply as it always has. Stone, water, air, and life bound together. Story is one of persistence, of patterns reshaped again and again, of balance, fragile yet enduring. And so the words drift now into silence. The planet continues, whether watched or unwatched, whether known or forgotten. Its oceans keep their tides, its continents keep their drift, its skies keep their turning. The story fades into quiet, into patience, into rest. Sleep well, under the same sky that has turned above Earth for billions of years.